My name is Richard Furr, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family, I'm cloud hired.
So I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the Glow Cloud team.
Welcome back, everyone. We are here for day 3, session 5 of our AWS Advanced Networking course to help prepare you for the ANS-C01 exam, and this is a full AWS networking specialty course. My name is Michael Gibbs. I am joined here by Mo and Benedict, and we are your instructor team for this AWS Advanced Networking course. Before we begin, I'd like to tell you about a few things in case you just got here. What we're doing is we're doing lectures because we have so much information to cover for the 3 full days, but there's also almost 2 full days of labs. Labs on AWS for the AWS Advanced Networking curriculum, and also labs that we've actually done in our data center for you, and here's why. When you configure something on the AWS cloud, you're not going to get to learn a lot about how it actually works at the underlying level because it's a cloud and it's hidden from you. So we actually did the AWS labs for you, which we'd love you to do, but we also have those that we've done in our data center. And we're walking through the switching and the routing protocols and how things work at the fundamental level. So you can learn how to not just configure, you can actually learn how things work, which is going to be critical for any type of a cloud architect career or any type of network engineer career or network architect career or cloud network architect career. So we're doing this for you completely free. If you've just joined us, invite a friend. Takes a lot to put these kind of things together. costs almost as much as a car by the time you're done with all the people be in the back end and the foreground and everything necessary. So please invite some people. We want to help you begin.
Hey, Mike.
Hey, Chris.
So I wanted to make sure. Did you see the student that got the new job, the cloud hired?
I did. The student in Orlando that got a job this morning.
Yes.
Yes, I'm always excited every time one of our students gets a great architect job.
Sorry, it's a Sunday, and it's a great way to wake up on a Sunday.
It really is. You know, our whole point around here is not just to passing a certification. It's to change lives and help people get hired. And every time a student in our cloud architect career development program gets a new architect job, it's kind of like for me, it's like when I got my first job the first time in tech, over 25 years ago. It's a long time. So we're going to continue the content. Chris,
yeah, I've got my camera off because I'm doing my dance. Nobody can see my dance. So.
Well, that's true. We all have a different level of happy dance. My feet are a little goofy, but from some injuries. But we do all have a happy dance every time someone gets me hired. So while we're at it, give me a hashtag cloud hired and a hashtag AWS Advanced Networking, and then we will begin. Okay, so we're going to begin by talking about CloudFront. And I'll be discussing CloudFront, and then, we'll go through a lot more content today. But let's begin with CloudFront. CloudFront is the Amazon-branded content delivery network. And what a content delivery network really is it's a network plus a geographically distributed group of servers. And the whole point of a content delivery network is to provide fast delivery of internet content. Content delivery networks are often used to reduce bandwidth costs because, especially in the cloud, you're paying for the at least you were paying for all the traffic egress, but you're still paying for a lot of those interregion type charges. So if we can push the content directly to the content delivery network, or at least based upon request, we can reduce some of our our network transfer costs along the way. So hope that actually makes some sense here. And the other reason we're going to leverage content delivery networks, and this is probably the most important reason besides the scalability, is the DDoS mitigation. And content delivery networks often dramatically enhance our website scalability. And the reason they do so is they won't send illegitimate requests to the servers. And by doing so, a content delivery network can help mitigate, say, a DDoS attack. For example, and I briefly covered it yesterday, if I want to do an HTTPS request or an HTTP request, and I request data and it's sent to me, life is good. But if I were to initiate, 10,000, 50,000, 100,000 TCP half open requests to the web server, it will take those resources from the web server. The web servers will be waiting to respond to the half open request, and they're not going to get a response, and it's going to use the capacity of the web server. So with content delivery networks, malformed internet requests don't get sent. Any type of anomaly behavior that's typically bad is typically not sent to the web servers, and that can reduce DDoS protection. And if you think about it, if for some reason your web server were to go down for, say, 5 minutes, there's a good chance that the information is actually cached on the content delivery network. So if a web server has to be rebooted, there's a chance that some of that content will still be served. So it can provide some additional high availability information when needed. So let's talk about performance. CloudFront can really help improve website performance, and it's going to be integrated into numerous AWS services. And CloudFront actually has a network of caching servers that's going to be spread throughout the world. And what's going to happen is when a user makes a request to a web page, their geography is going to be determined by their IP address. And then they will be sent to the closest CloudFront server, which is going to be cached to them. And the local CloudFront servers will cache the information until the TTL wears out. So it will minimize the amount of time that people actually have to wait. So we're going to walk through this. Now, I want to make it very clear. In a high availability situation, one content delivery network is not enough. And if you were to open a terminal window or a command prompt in Windows, and if you type NSLOOKUP www.amazon.com, and all of you did it, some of you are going to see that you're going to connect to the Amazon CloudFront content delivery network. Some of you will be connecting to the Fastly content delivery network. Some of you will be connecting to the Akamai content delivery network, because Amazon wouldn't let themselves use a single content delivery network because they need high availability. So they're going to use multiple content delivery networks. So when it comes to high availability, think multiple clouds, think multiple content delivery networks. But we're talking about the AWS content delivery network, which is a great content delivery network. But if it really matters and if it's really mission critical, don't use a single content delivery network. So here's the way a content delivery network is going to work. I've got some data over here from, say, the client. Let's say, for example, the information is going to be common information. So the first request, what you're going to see, is going to be from the host or the user. They want to receive something. So they send a request, and their IP address is going to be determined. They're going to hit the local content delivery network location, and it's going to pass through CloudFront. If it's the first request, CloudFront won't have it. So the local CloudFront area will be sent to the regional cache. If the regional cache doesn't have it, it's going to be sent to the source. So in this case, it's a static website. The source of the internet content is the S3 bucket. It will be sent from the bucket to CloudFront, and now CloudFront will cache the information, and then it will be sent to the client. Now, the next time we have a client that requests the same information, you'll see the request will go straight to CloudFront, and then it'll come straight back. So, for example, let's say we had a Taylor Swift who wanted to tweet a photo of her cat. And who doesn't want to see a photo of a cat? And I know a lot of Taylor Swift's got a big fan base. So Taylor Swift sends a photo to of her cat. Poof. Everybody wants to see it. That first request in a geography goes to see the cat. And all those other requests don't make it back to the website. So we can have 1 million requests coming out of the same area, and only the website has to process the first one. I hope you can see how that will help our web scale. So caching enhances scalability, and it can make a website much more scalable by offloading frequent requests. Now, if a website's serving all dynamic content and it's completely different dynamic content, and it's going to change all the time, and none of the users are requesting the same thing, then a cache isn't going to help. Caching is useful when the content is frequently requested. So I hope that makes sense. Now, CloudFront's integrated with a whole lot of AWS services, so it's going to make it easier if you're using AWS. Things like S3, your EC2 instances, your load balancers, your DNS, they all kind of integrate fairly nicely with CloudFront. And CloudFront is often used as a front end for static websites, and CloudFront can also be used for a dynamic website if it's based on EC2 and a load balancer as part of the architecture. So what would it look like in a non-static environment? Well, it would look fairly similar to this. You'd have your users, they'd access CloudFront. The static content would be coming out of your object storage bucket, or S3. And your dynamic content would be served by your virtual machines that are sitting behind the load balancer, otherwise known as EC2 instances. There's some key concepts we want to talk about with regards to CloudFront. And these concepts are going to show up in AWS exams again and again and again. So let's go over them. We're going to talk about the distributions, the origin, and then we're going to talk about the cache control. So when you set up your CloudFront content delivery network, you're going to need to set up a distribution. And the distribution is going to be identified by your DNS name. And this is going to be a very ugly name. If you all go and do an NSLOOKUP www.amazon.com, what you'll see is you're going to get something that looks pretty ugly. In fact, I'll do it real quick. So www.amazon.com. And what I'll do is I'll actually take this information and I'll paste it into a slide for you to see. I'll share this information with you. I'll try to make this as big as I can so you can see it. And then I'll share this slide in 1 second. Let's see how big I can make these slides. So in this particular environment, I did an NS lookup from my system right now. You can see that my DNS servers are 8.8.8.8, which are Google's DNS servers. You can say I received an answer for Amazon.com. And this ugly thing over here, that's actually the location of the CloudFront distribution. See how ugly this thing is? I mean, seriously, who's going to remember this? So the point of this is when you've got something ugly like this, what you're going to do is you're going to create a CNAME record to map Amazon.com to that ugly thing. And then all your users have to think about is Amazon.com. So kind of keep that in the back of your mind. It's not going to be any big deal. So we talked about the distribution. Now let's talk about the origin. When you set up CloudFront, you have to set up the origin. What's the origin? It's where your stuff or your content's coming from. So if your things are stored like you've got videos or photos in an S3 bucket, that's your origin. If you've got a virtual machine, for example, and you've got an EC2 instance, that's your origin. Or it could be the load balancer that front ends the virtual machines of your website. And the origin is going to point to the DNS name of this location. So let's talk about the cache control. Whenever you store information in a cache, it's going to be there for a period of time. And let's talk about caching. So the longer the information is stored in the cache, let's say, for example, I've got static information and it's a photo of my beautiful little Cindy the cat. She's real cute. If you want to see Cindy the cat photos later, I'm happy to share them. But if it's a photo of Cindy the cat and all my website is going to do is share Cindy the cat, and I were to set the TTL to a month, for a month, the photos of Cindy the cat are going to sit in the remote locations after they're requested. And for 1 month, nobody's going to have to, my web servers are going to do nothing. But what happens if each day or every few hours I post a new photo of Cindy the cat on this website? Well, no one will see it or know it because the information will be cached. So think about it this way. The longer the information is on the cache, the less work your servers do. But the less frequently people will see your new website. So you can modify this by setting the TTL. And there are any of you that have ever worked with caches in the past, you may notice the memory in the cache gets corrupted, and occasionally you need to clear it out by clearing the cache, and you can do that with a CLI command. So keep that in the back of your mind. Now the default cache is going to be for 24 hours. And what this means is the information won't be refreshed for 24 hours. But you can tune this any way you need to based upon your application. So how do you get this set up? We're going to take our web servers and we're going to put our content on them. Then we'll create a CloudFront distribution. AWS will assign that ugly looking name that I just showed you. And then we can either accept that ugly looking name for our content delivery network, or we can create a CNAME record to map something that's user friendly to it. And then AWS will provision the edge and configure the edge locations. So as you can see, architecturally, it's going to look like this. We've got our giant area, which is a region. Inside of that region, we've got our availability zones, which are otherwise known as data centers. And then we've got our edge locations. And you can also see in this particular example, we've got our users. And again, I'm going to work through this user flow with you one more time. Each one of these locations is different. So here we've got a user over here. They want to go to www.gocloudcareers.com. This user hits the local edge location. It doesn't exist at the local edge location because nobody's requested it that day. It goes to the regional cache. The regional cache doesn't have it. It's sent to the origin. Now, the message is sent back to this user. Now, the next user in that same edge location requests the information for the same thing. Request hits the edge location. The edge location sends the information back, and the user is happy. But let's say the first location is Miami, and the second location is New York. The user over here and now in New York wants to get the information that's not going to be cached on their edge location. So it's going to have to be sent to their edge location. That's going to go to the source, and then it will be sent back. And then until that cache expires, everybody on, say, this New York location over here will receive it. So typical content delivery network things, and this is going to work this way on everybody's content delivery network. It doesn't matter. So let's talk about a few more things. So let's talk about private content. Typically speaking, when you think about a website, And a content delivery network is for the rest of the world. But what if you don't want to use it for the rest of the world? What if you want to use it for paid website subscribers or a private application? Well, there are really there are a few ways that you do this. What you're going to do is you're going to set up an origin access identity in CloudFront, and you're going to restrict access to, say, that S3 bucket to certain individuals. We can also use signed URLs, and we can also use signed cookies. So let's talk about pre-signed URLs. There are times where you want to actually share information with someone, maybe out of an object storage bucket, and you can sign the information with your identity and access management information. And how you sign that information will actually determine how valid it is. So here's your basic methods of pre-signing a URL. You can sign it with your IAM instant profile, and that's going to be good for upwards of 6 hours. You can sign it by using the security token service, which is going to be much more dynamic and more secure because the tokens are constantly changing, and that's why it's good for 36 hours. You can sign it with an IAM user account, and it's going to be good for upwards of 7 days, or you can sign it with a temporary token, which will be good until it expires. So a little more about CloudFront. Any content delivery network can really improve your website's performance because your content's cached. And the AWS CloudFront Content Delivery Network has got a fairly good global reach. When we made this training, there were 217 points of presence or locations where you could access CloudFront throughout the world, pretty much every major city. And the other thing to remember is it's a private network. So normally speaking, when you go to the internet, you get routed all the way through the internet. And that's okay, but internet bandwidth is not guaranteed. With a content delivery network, once you jump on the content delivery network, you are on that content delivery network as opposed to the public internet. And by doing so, you may get better performance because the provider can sort of come up with certain guarantees of their own systems, but not other people's systems. So you get some routing efficiency. And CloudFront will maintain persistent connections, which means it's going to maintain connections with the stores. So there's no need to start a new session with the web server for every possible request. So it's going to promote some scalability. Now, CloudFront can easily integrate with your web application firewalls and your AWS Shield for DDoS. Look, if you're going to protect your web application, there's a time and a place for a WAF, but please understand that next generation firewalls and those firewalls with the enterprise-grade features and functionality from the security providers like Palo Alto or Cisco or Fortinet probably offer you some greater protection and greater enterprise features over a standard AWS WAF. But, it's an AWS certification, so you can secure your CloudFront with WAF and Shield and maybe use AWS WAF with some other more industrial tools. Or you're going to be multi-cloud and you're going to use more industrial tools for everything, and that way you can run similar security policies. And remember that CloudFront, like any other content delivery network, can really help prevent DDoS attacks. And it's going to do so by distributing your requests through multiple points of presence and only forward legitimate requests to the server that aren't already in the cache. And CloudFront can provide encryption in transit, which is great. It can enforce your SSL/TLS protocols. CloudFront will integrate into the AWS Certificate Manager, and CloudFront will support server name identification. Now, at this point, we'll come back. I'll come on screen. If there's any short questions, we can answer them. And then another member of my team is going to start talking about some really cool things in the world. Question from Jay Waynet. How does the cloud provider know if the request is static or dynamic based upon the information you shared with the load balancer? How does it know where the source is that you configured it? So, it's going to have a location where the information is. So either one of you want to touch that, but to me, it's where you're going to configure it. Benedict or Mo, do you have an answer there?
Not really.
Okay.
Yeah.
Yeah, I'm not understanding the question, honestly.
I didn't either. So maybe if you rephrase the question, we can help answer that. From Emmanuel, what is the difference between CloudFront and the edge location? CloudFront is the content delivery network. The edge location is really a building where the caching servers are stored for the content delivery network, and also a lot of your internet providers are there. So it's something that's going to be called the point of presence, Emmanuel. And what is a point of presence? A point of presence is a building where basically your internet service providers have all their wide area connections in. So let's think of the world's largest internet service providers. Telefónica in Spain, Vodafone, Orange, NTT, AT&T, Verizon, CenturyLink, Etisalat in Dubai is a fairly large one, and there's a few others, but you said that are big. So here's the thing: the way internet routing works, Emmanuel, is if I want to go to a website, if I'm on AT&T and the provider's website is hosted on Verizon, I have to take my AT&T network and it has to connect to a Verizon router somewhere, and then it's going to get on the Verizon network and be taken to wherever the information is. Because a point of presence has every one of these providers go in there, and they put these big wide area connections, and they're all in the same building. To connect them is very simple. It's just a switch-to-switch connection, or a router-to-router, layer 3 switch to layer 3 switch, and they're already there. So what happens is Amazon has got these big giant buildings, and they're filled with internet service provider connections, and they fill in with their caching servers, and you can literally jump on off of one of these ISPs and directly onto the content delivery network. So edge location is the building where the CloudFront content delivery network is stored.
What is the purpose of assigned URL in a use case? Well, in the context of AWS, usually assigned URL, you get more control over who accesses that URL. For example, if you have some content that only specific people have access to, you can have that that URL basically, for example, expire after a certain time, or only certain users can access that URL. So you get more, let's say, more control over who can access your content with assigned URL.
So I wanted to come in here. I think Jeremy helped us out here with the original question from Jab WeNet. So Jab WeNet was originally asking, how does the cloud provider know if the request is static or dynamic based on the diagram that you shared? So the diagram that you shared actually showed the content.
Yes.
So the request, so Jeremy added this. He said the request isn't static or dynamic, but the content. So so back to Jab's question, it's not the request that's static or dynamic, it's the content that's static or dynamic.
Yeah, and I think we didn't understand the question, and that's a good point, because if it's going to look for, say, a video of a cat doing flips, it's going to point to something that's probably .mov or .mp4, which is going to be sitting in the object storage where the hyperlink is going to be. If it's looking to run a script, it's going to be on the server where the script is. But yeah, Jeremy, I thank you for translating that. I think that's what he meant. And if it's not, just please let us know. Any others? All right. So if there are no, see if you have any other questions. And if not, I think we're going to get to Mo. I think you're up next.
Yeah.
All right. So if you just joined us, remember to download those AWS labs, because there's about 2 full days worth. And otherwise, Mo, over to you.
Okay.
If you could bring in the cat, that would be great.
right? he's just moving all over the place, just playing. He doesn't like to be held. So, usually he just play around. Actually, I see him right there, but he wouldn't come over. Okay, so we're going to start with geo restrictions, right? And geo restriction or geographical restriction, right? Sometimes called geo-blocking. It's a feature of content delivery network. Okay, so as we know with AWS content delivery network solution, which is called CloudFront, right? You get to use AWS Global Infrastructure, right? Sending your traffic to the nearest edge location in order to use AWS reverse proxies, right? Reverse proxy is just a word for a server that establishes the sessions on your behalf, right? So with geo restrictions, what we're trying to do here is using those basically restricting access to those proxy servers, right? Or the content delivery network solution. And so what you do is AWS has a database of all the IPs mapped to a geographical location, right? For example, those IPs are, this pool of IPs of range is for North Africa, and this range is for, and even as specific as to certain countries, right? This IP is for Egypt, and this IP is for Libya, and this IP is for Morocco, and so on and so forth. And so with geo restriction, you're able to say, I would, for example, whitelist only certain countries or geographical locations and say only those countries can access my content. For example, let's say it's a government website and they only want people to access their content from within that country, right? So that's one thing they can do, right? Or maybe it's a content that's only meant for European countries and they can make that content only accessible from those countries within that region, right? And according to AWS, the database that they maintain is 99.8% accurate, right? So the accuracy of the IPs mapped for different countries or geographical location. And this is a visual representation. If I share my slide, if you look at this diagram, you see to the left, we're not using a content delivery network. We have a user from Egypt accessing content in France. Now, the server in France, they can have their own logic to say, to permit and deny IPs based on, if they can maintain their own database and they can deny IPs based on geographical location, right? And it is possible. But the benefit of using a solution like, if you're already using content delivery network, right, you get to deny those users access. For example, let's say this content should only be accessed within Europe, right? Then you can just whitelist the European countries and then just deny access outside of Europe, right? And the benefit here is that since you're using a content delivery network, your server or your data center doesn't have to process information from locations that shouldn't be allowed to begin with, right? So with using content delivery network, you already have that added benefit of only processing requests that are meaningful, right? For example, your content delivery network can scrape that traffic for you. But also, if you want to restrict access to certain countries, and then you can either whitelist or blacklist those countries, and the load on your server will be much, much less, right? You don't have to process information that is not intended to access your content. Now, with content delivery network, we have two types of content delivery networks, right? you have simple geo restriction, right? Or a standard, apologies, let me go back. So you have two ways to do this, right? You can do geo restriction as a whitelist or as a blacklist, right? And it's common sense if you think about it, right? When you do whitelist, that means you only whitelist specific countries if it's a short list of countries, and then everything else is implicitly denied, right? Or you can do it the other way around, right? You can blacklist only certain countries and then just allow all other countries. And again, AWS, they handle that database for you. They have a database of IPs, and it's 99.8% accurate according to AWS. Okay. When you deny access to your website, right? By default, the user will see for example, if it's a website and you type that website and content delivery network blocks you, the typical response you get is a 403 status code, which says forbidden, right? But you can change that default behavior, right? For example, if you want to give them a response that says content not found, or maybe deliver the denied user a web page that has a message that says, the content, you're not allowed to access that content, right? And so on. Or maybe you want to redirect them. And so, but the default is that, you just denied, you get an error 403, status code 403. Now, if you can integrate content delivery, AWS content delivery network with third-party solutions that would allow you to permit access only to certain files or deny access to certain files. Let's say, for example, you have an S3 bucket, and instead of just allowing full access to the S3 bucket, right? Let's say the same example, we're talking about Egypt and France. You want to allow Egypt access to the server, but only to specific file paths and not to everything else. So this is not available within AWS, but AWS does allow you to integrate their content delivery network solution with other services that have that level of restriction or that level of control over who can access your content, or what part of your content do they have access to, right? So what's the benefit of using geo-restriction or geo-blocking? Well, the first thing is legal compliance, right? Sometimes you have laws that prohibit you from sharing content with certain countries, or maybe prohibit you from sharing content from outside of that country, right? What if you want to restrict content or deliver certain content only to a specific city or a zip code, right? That's also possible, but it's possible by using third-party solutions and integrating those third-party solutions with AWS. But as of now, AWS solution only allows you to block or restrict access to certain countries. Now, the second benefit here is a security enhancement. Since you can block content from certain countries, maybe countries of non-interest, right? Or if there's a certain country that you get a lot of DDoS attacks from, then you can just block access from that country, right? And of course, gives you more control over your content, so you can deliver the content only to specific regions, right? Okay, let's move on. So this is what geo-restriction is, or geo-blocking is. It's a content delivery network feature, right? But it's not activated by default. You have to activate it and set it up to allow or restrict access to or from specific countries. Global Accelerator. What's AWS Global Accelerator? So an AWS Global Accelerator is a service that gives you an optimal, or gives your customers an optimal experience, regardless of their geographical location. So what AWS has a large infrastructure, right? It's a large global infrastructure, right? And they have those internal pathways that allow them to circumvent the public internet and not have to use the public internet, right? And they have over 100, I think about 110 points of presence, right? Which what we call edge locations, right? So they have over 100 edge locations, about 110. And so if you use Global Accelerator uses or takes advantage of those points of presence so that you can allow your clients to access your content as fast as possible. And what I mean by that is, what you're doing is what sometimes is called, for at least in the realm of connectivity providers, what they call mid-mile optimization, right? Because the first mile is the client, the last mile is the website, the mid-mile is everything in between, right? So you want to limit the time the client has to access the public internet before they reach your server, right? And so if the client only has to traverse, let's say, 3 nodes before reaching a point of presence, then that point of presence has a reliable, since once they hit that edge location of point of presence, they're using AWS internal infrastructure, right? You know that you have a reliable and fast customer experience from that point of presence moving forward, right? So that's the benefit of using those edge locations, right? So Global Accelerator, using those edge locations and using AWS internal infrastructure, what they do is they advertise when you want to use Global Accelerators. What AWS allows you to do is advertise 2 public IPs, right? And those 2 public IPs will be advertised from each edge location, right? So it's basically Anycast, right? IP Anycast. If you know anything about Anycast, it just means that what you're doing is you're advertising the same IP everywhere. For example, if you know Google's DNS address 8888, right? That's Anycast, because it's the same IP advertised from multiple locations, and you just by byproduct of the public internet, byproduct of routing, BGP, you will be able to access the closest server possible that hosts that 888 IP address, right? That's Anycast. And so by using Anycast, AWS allow you to advertise 2 public IPs, and those public IPs are advertised from all of the points of presence, the 100-something point of presence. And so the client will reach the closest node or the closest point of presence, topologically speaking. And the reason why I say topologically and not geographically is sometimes, let's take a simple example. Let's say we have Libya and Egypt, right? Libya and Egypt are right next to each other, right? And if I'm running a highly congested cable between Libya and Egypt, and it's a low speed, then even though I'm right next to Egypt, it might make more sense to go through, and again, this is not a practical scenario, but just as an example, it might make more sense to go through Italy and down to Egypt if I have a much higher bandwidth or a much higher speed through Italy, right? So even though Egypt is geographically closer directly, it might be topologically speaking, it might be faster to go through Italy and down, right? So this is why we say from the network's perspective, right? Topologically speaking, which location is closest, right? Okay. So there are two types of accelerators, right? Or acceleration. So there's a standard acceleration, and then there is the custom acceleration or the custom routing acceleration, right? So the standard acceleration allows your application to be available and work well for users globally, right? So it does the job, but it just gives you the ability for your clients to reach your content in the fastest way possible, right? So basically, you advertise those same IPs everywhere, right? And then they're advertised through BGP's global routing table, right? And then your edge device will send your traffic to the closest edge location topologically, right? And so with the standard acceleration, that's the benefit that you're getting, right? You reach the point of presence, and then from that point of presence, you get to send your you get to deliver the content through AWS private network. Now with custom routing, you get to do a little bit more, or you get a little bit more control over where to send your client's traffic, right? And here's an example, right? Let's say you're using global accelerators, right? But your servers are not only available in one region, they're available in different regions, right? So let's say you have your content in one of AWS Europe regions, more content in the Americas region, and some content in the Asia Pacific region, right? And so with custom routing accelerator or custom accelerators, you can say, I only want to send my content if my content is arrives from or lands at this point of presence. I want to send it to the Europe region. I don't want to send it to the Americas region. And this can be really critical for some type of applications, right? And a very simple example, if you've ever played online games, right? You know that when you play for a certain server, you're subscribed for that server, right? All your progress, all your whatever character you're working on, all that progress is in one server, right? So it doesn't make sense to be redirected once to Europe server and then tomorrow to APAC server, right? Because you have no progress in the APAC server, right? Plus you have the latency issue. So if let's say if you're in Egypt, it makes more sense to be in the EMEA server than to be in the APAC or America server, right? And so custom routing accelerators will allow you to do is map each region to a specific port number, right? Let's say your application is using HTTPS, but it's using a certain port number, let's say 4343, right? And then you can map 4343 to the EMEA region, right? So if a client in the actual application in a game, if they choose the EMEA server, then when they send the traffic, they send the traffic with a port 4343, and then from the global accelerator, I can map 4343 to the EMEA region, right? And let's say 4545 to APAC region, and so on and so forth. So it gives you that kind of control, right, with the custom routing accelerator. And of course, when you deliver content, you need to deliver your content to something, right? As we said, our servers. So those targets, or what we call them are resources, right? They can be EC2 instances, they can be load balancers, whether it's application or network load balancer, and so on and so forth. Okay, so why would you use global accelerators, right? Well, number one is you get better performance, right? So instead of sending your traffic to the server using the public internet all the way, you get to use AWS Global Infrastructure to send the traffic to the nearest location possible, right? So you get the benefit of, having a more optimal performance because you're using mid-mile optimization, really, right? You're reducing the time, that you have to traverse the public internet, right? So you get mid-mile optimization. The second thing is you get more flexibility control over where you send your customer traffic, right? So you can optimize it based on their geographical location and send your traffic to a certain location. And then the third thing, and I think it's a big reason why you might want to use global accelerators, and I touched on it initially, which is Anycast load balancing, right? We said you're doing Anycast, and with Anycast load balancing, right, because some applications don't handle or don't support using DNS, right? They don't support using DNS-based load balancing. And so using Anycast is an alternative to still, have load balancing without having to support DNS-based load balancing, right? Okay, so that's global accelerators. We touched on geo restriction, which is part of content delivery network. And now we touched on global accelerators and a different type of global accelerators. Now we'll move on to connection draining, right? So connection draining is part of elastic load balancers, right? It's a feature of elastic load balancers. So basically, connection draining allows you to gracefully shut down an AWS instance or a resource, right, without interrupting existing client workloads or traffic, right? So think of it this way, right? You have an elastic load balancer, right? And based on demand, you had 2 EC2 instances, and based on demand, you had to scale out from 2 instances into 6 instances to support the workload, right? So after peak hours, the demand went down, let's say, by 50%, and you no longer need 6 EC2 instances, now you only need 3. Now the problem here is because your load balancer is load balancing the customer traffic between those instances, if one of your customers is still using one of those servers that we are about to shut off or scale down, right? That can cause an issue, right? Because maybe it's an e-commerce website and they still have an active shopping cart, and if you just shut down that website, they might lose that, right? Or maybe they're downloading a file, right? And they're gonna lose that progress. So you don't want to immediately just instantly shut off that instance, right? You want to have a little bit of a grace period, right, before shutting off that instance. So connection draining basically starts a timer, right, before shutting off that instance. And then it will direct all new traffic to the instances that will remain, and it will not send any traffic to the instances that will be shut off, right? So all the new traffic will go to the existing instances that will stay, but then no traffic will be sent to the instances that will be shut off after, let's say, 6 minutes, right? And then during those 6 minutes, your existing clients will have enough time to download or finish whatever work they're doing, but all their future sessions will be redirected to the other servers, right? And then after that grace time or grace period expires, then you will shut off those instances, and hopefully you've reduced the amount of disruption, right? So it allows you to have a little bit of a grace period so that your user experience will, that will enhance your user experience slightly. Okay, let's look at this slide. Look at this diagram. As you can see here in this diagram, let's assume that we have 2 users, right? And you have 3 instances, right? And user 1 sends traffic to EC2 instance 1. User 2 sends the traffic, and the load balancer sends the traffic to EC2 instance 3, right? Let's say after some time, the traffic load has dropped by 30%. And we no longer need instance 3. So we need to shut off instance 3, right? If we shut it off immediately, then user 2 loses access, or disrupts user 2's existing session, right? Let's say user 3 is downloading a file, right? Now, with connection draining, your elastic load balancer, before scaling down, scaling in, I guess you can say scaling in or shutting off instance 3, it will start a grace timer, let's say of 5 minutes. And during those 5 minutes, all the new sessions, say we have a new session, all those new sessions will be sent or load balanced between instance 1 and instance 2. So no new sessions will be sent to instance 3, right? Only the existing clients will be sent. The existing clients that already made a connection with instance 3 will be sent to instance 3. So it's user 2 in this example. So after the 5 minutes expire, this instance will be shut off. And then all future traffic from user 2 will be either sent to instance 1 or to instance 2. So that's basically what connection draining is, right? It can be very beneficial to maintain or to enhance the user experience, right? And not having a disruption. So why would you use connection draining, right? Well, as we just said, right, you get a seamless user experience or a better user experience, right? So you avoid an abrupt termination or shutting off because of shutting off an EC2 instance, right, or whatever resource. You get more reliable application performance, right, and then you reduce the risk of data loss, right? As we would just mentioned in the example, we said because your user is downloading files, right? If you just shut off that instance, all that work, all that progress has been lost. But since you have a grace period, right, the user will have some time to finish the progress, to hopefully finish the file transfer or whatever, right? Okay. Let's move on to the next subject. So the next subject is TCP, or actually let's take some questions first, since it's going to be next topic is a little different. Okay, do we have any questions?
Welcome back, everyone. Do we have any questions at this point? What is the purpose of signed URLs? So I can give you access to information via one of 2 ways. I can create an identity and access management entity to you, meaning, say, Benedict O, and then I can determine what Benedict O's rights are. But what if I just wanted to send you a video? and I didn't want to create an account for you, and I just wanted to assign one thing with my URL and give you complete access to it. That's typically why we use signed URLs. Now Tundi, you actually asked a very good question. How do you ensure geo restriction is not being bypassed by using VPNs? Now, Tundi, I can tell you a lot of people actually bypass organizations and governments, entities of them. For example, there are countries in the Middle East, wonderful countries that I've worked in, that certain types of content are deemed illicit or inappropriate. And in these typical organizations, they typically run everything through a proxy server. And a proxy server has a blacklist of sites that can't be seen. And by using the local internet, you get sent to the proxy server. The proxy server says, no, you can't see this. So there are people that would actually create a VPN and go back to, say, the US or the UK. And by doing so, they are no longer have an IP address because they've tunneled through the internet of exactly what you're doing. So I'll see, is there any way that you guys can think of to kind of block that? Unless you were to block IPsec and block TLS.
Yeah, pretty much you have to block IPsec, and that's actually something some countries in the Middle East do. I know China does that too. I know Egypt for a fact does that, right? I worked on a project where IPsec was blocked, and we had to basically, through the service provider Orange, we literally had to like sign a form and submit to say we wanted those IPs, VPN to be allowed from here to our data center in the US, to our data center in Europe. So we had to actually, submit a request, and it took about a week just to get it approved. So yeah, I mean, unless you're gonna block VPN, there's really nothing you can do, right?
Can you draw out the Global Accelerator with 2 public IPs to explain?
Yeah, sure.
Now, we did draw out an Anycast thing yesterday, which will help. But Mo, you want to do that, or would you like me to draw an Anycast?
No, that's fine. I'll draw it out.
Okay, great.
Give me 1 second. So let's do an oversimplification here. And let's say we have 3 points of presence, right? Or edge locations. So those edge locations are buildings or data centers or buildings that are owned by AWS, right? So let's say one is in APAC, one is in EMEA, and is in Americas, right? And so between those points of presence, right, you have very fast channels that connect the whole AWS global infrastructure, right? And this is private. Doesn't touch the public internet, right? And you have, of course, you have connections to all of the AWS data centers. Let's say you have content in this data center here and in this data center here. right? Content in A and B. Okay. So you as a user, right? You as a user, let's say you exist here, somewhere behind APAC, right? Let's use a different color. Right. And you're using the public internet, right, to access this content, right? So using the public internet, you should be able to access this point. You should be able to access that point, right? You can also access this, right? AWS data center, right? It's all available on the public internet. Now, typically without a global accelerator, right, you would just advertise your content, right? The IP address of your content. AWS takes care of that for you, right? They already advertise the content, but those are different IPs based on the location. Now, with content delivery network, what you do is you get access to two public IPs, right? Those two public IPs, if you're using only IPv4, so you get two public IPs. If you use IPv6 as well, then that means two IPv4, two IPv6, so that's 6 public IPs. So you get two public IPs that you advertise out of each point of presence. We said we have 3 points of presence, right? So you're no longer, this IP is not advertised from here. No, it's advertised from the points of presence, which means it's advertised from here and from here. No, not really. It's advertised to the public internet from here, and from here, right? So it's the same IP, right? So in your routing table over here, this is your office, right? You're a customer. Your routing table, you might see, if you have the full BGP routing table, you might see all of them, right? You might see this public IP that's coming from here, and from here, right? You'll see the 3 of them. But one of them should be have a better reachability, right? Based on BGP's attributes, right? And we're not going into BGP's different attributes, but most likely it's going to be based on the autonomous system path, right? Basically, how many different autonomous systems or how many organizations you pass through to get to from point A to point B. So let's say in this example, this one is the fastest, right? The one through APAC. And so that's the one that you will use because you're coming from here. That's the one you will use to reach that IP, right? And so you will send the traffic through internet to the nearest point possible, which is the point of presence or the edge location, right? And this is what we call it mid-mile optimization, right? So now you reach this point of presence, and then from this point of presence, you'll use AWS Global Infrastructure, not using the public internet, but AWS Global Infrastructure, and send the traffic over here, right? Of course, if you have the same content on both regions, then you get the option to send it to the closer location and send it over here, right? This is also things that you have control over, right? Do you want to send it to the data center in this region or the data center of this region, right? Let's say if we have another customer, but this customer is behind Americas, then as a byproduct of BGP, the public internet, you'll reach the nearest, the closest topologically available, the closest point of presence, topologically speaking. And so the traffic will hit this edge location, right? So you traverse the public internet and you reach this location. And then based on the logic that you have within the global accelerators, you can either send it to this data center or this data center, right? AWS data centers, right? So that's basically the idea behind global accelerators. Now, we said there's custom routing policies or custom routing setups or policies that you can use to send specific users to or from specific regions to certain data centers, right? And we give you an example, like having you playing online games, right? And let's say you play an online game, and you, since you're from Americas, you subscribe for the Americas server, right? From the Americas game server, and so the application maps each server to a port number, and so regardless where you come from, regardless what location, if you choose the Americas server, and then you access you hit the point of presence with that special port number, and we gave an example, we said 4343, and so we, in the Global Accelerator logic, we map 4343 to the Americas server, and let's say 4545 to server, and so on and so forth. So with custom routing policies, you can map users to certain servers in certain region based on the port number that they come from, right? So that's basically what global accelerators are.
Samsung, as far as the difference between direct connect locations and edge locations, which are both buildings, absolutely. What are the fundamental infrastructure differences between them, as both have POPs, vendor sus ISPs? So Samsung, two things. One is they're not going to allow us into these buildings for security purposes, but knowing what they do, I can explain it. Now, they're going to be very, very similar. So here's your traditional plane of presence. It's a building. Every internet service provider has their high-speed optical links that goes into that building, and they all have their own routers there, and then they just basically run cables between each other's routers through a switch, typically speaking. So there's that. That's your typical internet point of presence. And what's the point? Well, if I'm an internet service provider, let's say I'm AT&T, and I need links, long-distance links to NTT in Japan, and I need long-distance links to Telefonica in Spain, and I need long-distance links to BT in England, and I need long-distance, I'm going to pay a lot of money for these long-distance links. Now, if I just decided to get one long-distance link to England, and while I had that long-distance link to England, all the other internet service providers in the same building, I could create a long-distance link to England, a long-distance link to California, a long-distance link to Asia, and by doing so, each link could connect me to every internet service provider. That's your typical internet point of presence. What's a direct connection location? Well, it's a place where all your wide area network providers go into the same building and you connect to the AWS infrastructure. So it's very similar to an internet point of presence, but instead of every internet service provider connecting to every other internet service provider, every wide area network service provider connects to the AWS backbone. Same concept, slightly different use case. So now we're going to deal with an edge location. We have to have every single one of our internet service providers in there if it's going to be meaningful, for real. So we're going to have all those internet service connections coming in, just like we would in any other internet point of presence. But instead of connecting all the internet service providers to the internet service providers, we're connecting them to CloudFront. And then we have a whole bunch of servers that have a high memory that are doing caching and have lots of memory. That's your typical infrastructure differences, but they're all going to look and feel pretty darn similar, because any data center, any network that's full of network stuff, whether it's a cloud provider or a traditional internet providers, isn't going to be that much different. It's pretty much the same thing. All this stuff kind of reminds me, I think it was The Who. They had a song that says, "Meet the new boss, same as the old boss." Pretty much what we're dealing with here. William, this is actually a pretty important question you asked here. Is there any document that is possible to verify the latency between regions using Global Accelerator? Here's why there can never be a document for this, Willen. You don't own the network. It is a shared network. And as those routers and switches, have to heal if a cable gets cut, the latency and changes will be different. If there's congestion on the network, it will change it. So you're never going to be able to know exactly what you're going to get on one of these providers' networks. It's a little different if it's your own network and you own all the wide area network links and you can run a quality of service policy to guarantee it. That's what you have to remember with the cloud. It is somebody else's stuff. So we're going to lose that flexibility and we're going to lose that control. So what you're going to have to do is test. And we're not talking about going to some internet test and using a consumer grade testing website. You're going to have your QA engineers come up with scripts and start sending certain types of traffic and measure at different points of the day, at different weeks, at different months, and your mileage may vary. And then you'll get an average or an aggregate. I mean, don't get me wrong. Whenever you look at a vendor, they're always going to have their numbers. For example, I can point you to firewalls that say they can do 10 gig of stateful throughput. And then you turn on a bunch of features and they literally can't go beyond 100 megs, even though that's 1/100th of what they're able to do. So you're always going to have to test your workflows, but that's how you're going to do it. You're going to test it. These are good questions coming in today.
After the connection, the user still has something in cart. What happens to the user? Give me a second. Okay. To the user cart after the draining? Does the user see the draining effect? Well, if the timer expires, right, and then they still haven't finished, and that information is stateful, exists on that server, then they just lost that information. But that depends on the application, right? Is that information shared between different servers, right? And the server can continue the progress on a different device. So it depends, right? But really the biggest problem here would be if they're trying to download some content, and that content exists on that server, right? And that might be that's a bigger issue, right? So you're really buying your customer a little bit more time, while you're scaling down your applications.
All right. Well, I think we're ready to go back to the content. Are we ready to go to Lambda, or did you have anything left over there, Mo?
I have one topic.
I thought so.
Yeah.
I thought you had congestion control, but I wasn't sure. So before we go back to the content, if you're here and you're awake and you know what day it is, please give us a hashtag AWS Advanced Networking so we know that you're here and you're awake. While we're at it, if you just joined us and maybe you've missed the first couple of days, don't worry. You can watch the first few days on our YouTube channel. And if you just joined us, make sure to get your free AWS Advanced Networking lab demos. You're going to sign up for them. We've got 2 additional full days worth of training, both some things on AWS and also things in our data center, so you can truly understand how the technology works under the hood. I want you to get it. It's all free. So please download them. Mo, back to you to talk about congestion control.
All right. So congestion control, right? What's congestion control, right? As we know, TCP packets, right, or TCP flows, as we know, the protocol is more of a reliable protocol, right? You send traffic, and you can know when you send traffic, you will know that the traffic has been delivered, because each batch of packets that you send, you'll get an acknowledgement for your traffic, right? And of course, because when you first establish a TCP session, right, there has to be some sort of a handshake, right? Which is, we all know the 3-way handshake, which is the TCP sync or synchronization, and then your server will reply to you with a synchronization / acknowledgement, right? And then the client would send an acknowledgement to the server's synchronization, right? So that's the 3-way handshake, right? Once that session is established, both the client and the server will acknowledge each other's packets, right? So you request a packet, the server will send you traffic, and then you will acknowledge that you received, let's say, packets from sequence 100 to 120, right? So since traffic is sent over the internet, and we're not really guaranteed a certain bandwidth, right? from point A to point B over the public internet, right? It's really difficult to gauge the rate at which you should be sending traffic, right? It's not very straightforward, right? So TCP tends to be greedy in a way that it sends traffic, right? TCP tries to send as much traffic as it can, right? And if we just don't limit how much traffic TCP can send, then we might just end up, over exhausting our connection and then just traffic being dropped, right? Which is not very efficient. So TCP uses a feature that we call TCP congestion control, right? And basically what congestion control is a way for TCP to gauge how much it can send. So we'll work very aggressively, try to send as much traffic as it can. And then once it starts getting dropped, it will drop down, but then it will start less aggressively, knowing that if it go to 50% of what it did before, there won't be any traffic drops, right? But it will do that same idea where it will go up slowly instead of going aggressively initially, and then we'll go slowly up to the point where it hits a comfortable traffic rate where it knows that it's not going to get dropped, and it just continues on that path. And then we'll slowly keep going up until it gets dropped again, it goes down. So you still kind of have that yo-yo effect or going up and down, but at least now it's more regulated, and the rate between the top or the peak and the bottom is not big, and so you have more of a smooth traffic flow, right? So in this diagram, share my screen, I'll show you this diagram. So as you can see here in this diagram, we have the TCP congestion control mechanism, right? There is two phases of TCP congestion control. We have the slow start and the congestion avoidance. Okay. So you start sending applications. Your application starts, your TCP application starts sending traffic, right? You're just sending packets, right? You start with a maximum segment size of 1, okay? Which means you just send 1 packet. And then once you get an acknowledgement, you double that. So now it's 2, and then you double that. Now it's 4, and then you double that, that's 8, and then 16, and then 32, and 64, 128, and so you can see how it goes up very exponentially, right? It goes up really fast until you hit a point where your traffic gets dropped, right? That's when your traffic gets dropped, you start again, but this time instead of going doubling your traffic each time, now you are working slowly to basically send the traffic by increasing your the number of packets you send by 1 each time, right? So you go up. This time, as you can see, you're going up slower, right? And you're working your way up because of the first time you pretty much established a threshold where I can't exceed that, right? And so you just continue on that same half of what you peaked at, and then now you're increasing your traffic by 1, so you're working your way up slower, right? Instead of going 1, 2, 4, 8, 16, you're doing 1, 2, 3, 4, 5, right? So each time you get an acknowledgement. So the first time, and what this means is first time you send 1 packet, you get an acknowledgement. Usually it's not 1 packet, but as an example, right? Let's say it's 1 packet, you get an acknowledgement. So you send 2, you get an acknowledgement, and then you send 3. You basically you won't send more packets until you get an acknowledgement, right? So the window size, what we call your TCP window size, is how many packets you send before waiting for a response, right? You can't just be sending traffic without expecting a response, right? Especially for TCP traffic. And so let's say you send 3 packets and you get an acknowledgement for the third packet. And then you send 6, and so on and so forth, right? So initially you're just doubling, but once your traffic, you reach congestion, your traffic is dropped, and now you can start again and just working your way up slower, right? And as you can see, the traffic now smooths out until you hit a phase where your traffic gets dropped for whatever reason. If there's no traffic drop, and then you'll just continue on that path of working your way up slower, right? And that's what we call a congestion avoidance, right? So the initial phase is the slow start, and then the second phase is the congestion avoidance, where it's less aggressive and more stable, right? So you do a slow start when you ramping up, you're working your way up, right? And TCP always reevaluates, so it doesn't just work based on the initial congestion. It keeps reevaluating the speed that it can actually operate at or send traffic at. So already went through. We said the slow start phase, and then the congestion avoidance phase, right? Now there are other, and this is just a feature of TCP. There are other features, at least from the network side, that we use to deal with congestion, right? One of them is what we call, and it's more of a queuing method, right? And without going into too much details, right? There's by default, what you do is when your link is congested on a router, right? If you have an interface and your link gets congested, usually just by default, you just do what we call a tail drop, which means you have a queue because there's a buffer or there's a limit of how much traffic you can send through your cable, right? So or link. So if you get congested, what would usually happen is you start dropping the new traffic, right? That comes in, right? Because you got congested. What you can do is what we call weighted random early discard. And what weighted random early discard is, it will start randomly dropping TCP traffic. And the benefit of doing that is you signal to TCP ahead of time to slow down, right? You wait for TCP to get to a certain threshold, since you as a router can decide that, right? What the threshold is, and then once that threshold is reached, you start to randomly drop traffic. And when you start randomly drop traffic, and the reason why you randomly drop traffic, because you have potentially thousands of TCP flows, you don't know if you want to randomize a process so that you make sure that you're more fairly dropping traffic from different flows. And so when you start randomly drop traffic, you force the TCP flow to work into the congestion avoidance phase and work in a more consistent phase instead of just having that yo-yo effect of going up and down, right? So that's congestion avoidance or congestion control, which consists of 2 phases: the slow to start phase and a congestion avoidance phase. Okay, are we taking questions or are we moving forward? Okay, guess questions.
I'll take it. Yeah, let's take some questions here, and then I'll move a little bit. Are there any questions on congestion avoidance or that weighted red, which Mo was talking about, which is always a fun topic?
Look, I have a guest who decided to show up.
Oh,
No?
now that needs to go full screen. Yeah, my cat doesn't like when I pick her up either, but they're always loving and cute little things.
Okay. He doesn't love to be held. He's very nice. He's very friendly. He just doesn't like to be held.
I completely understand that. Well, if there are no questions, I will go get into the content with Lambda at Edge.
All right.
Before we do, if you're enjoying this video, please give it a like. It helps signal the algorithm to show it to more people. Subscribe, hit the bell, that kind of thing, so you can see new videos that we're going to create. And we've got some extra special content coming for you at the end of next month. So please make sure you're subscribed. Up and up, good to see you. And yes, I love the cat too. Okay, Chris, I'll go back and I'm going to start talking about Lambda at Edge. So Lambda is basically your typical function as a service. Azure has it as a function. Lambda has certain functions. And we would talk about that much more in, say, a solution architect training. But here's the key. It's a serverless function, which means it's a little piece of code that's uploaded. It does its thing. And yes, it does run on a server. It's just the servers are hidden from you. Now, what if you could run some of your Lambda functions at the edge of your network instead of actually having to bring it all the way back to your VPC? That's really what we're talking about with regards to Lambda at Edge. And it's allowing you to run a Lambda function closer to the user. And the way it's going to work is you'll set it up by, you'll upload your code, and then you'd set up, say, any type of HTTP notifications that you want. And the Lambda function would run whenever the code is triggered, and then you pay for things. So that's the thing with these event-driven architectures and these serverless architectures to keep in mind, architecturally speaking. When you don't use them very much, they are very inexpensive to run. I like to view it as kind of transportation. I like to think of a Lambda function as kind of like taking an Uber versus setting up your own virtual machine and running it, kind of like buying your own car. Now, if you live in New York City and you're only going to take 10 trips a month because you're going to walk around, it's probably cheaper to take $10, $20 Uber trips than it would actually be to buy a car and use a car. But what if, for example, you're like me and you live in Florida where everything is 10 to 20 miles away, and I go places, 3 times a day. I go to, say, PT in the morning, and then I potentially take my wife to dinner at night. Now, in that environment, I would realistically speaking, need 10 Uber trips a week or 40 trips a month, and they'd probably be $30 to $40 each Uber trip. And it's cheaper to, say, buy a car and pay a car payment than it would be to use the Uber. So keep that in mind anytime you get involved in serverless. You must know how it's going to be used. And obviously, you can create similar architectures with virtual machines, and then you'll just pay for the virtual machine where here you're paying as you use them. Keep that in mind. Now, when you upload the code, or I should say your developers upload their code, they can upload the code in, say, C#, Go, Java, Node.js, Python. And Lambda functions do enable that event-driven. If this happens, do this in response to this. So remember that Lambda is stateless, meaning it doesn't keep track of what's going on. So if it performs a function, once the function is done, it's completed. And if another function were to have to occur, you're going to have to set up functions in steps. And there's the ability to do that with something called AWS step functions as a general rule. Think of it this way. AWS Lambda is going to be useful in places where automation can increase the efficiency of your technology, decrease manual intervention. So if you want to process data across multiple systems and you could use Lambda to sequence it, great. I like, not that it's Lambda at Edge, but 16% of all cloud attacks, the last time I checked, were actually misconfigured S3 buckets on AWS. And you could have someone that puts in information on an S3 bucket, which is just object storage, and they set the permissions wrong, and the corporation could have a Lambda function that, as soon as it sees that, changes their permissions. You could use Lambda potentially to patch operating systems. So Lambda can be run in response to an event. Stick a new file in an S3 bucket, Lambda can run. So kind of keep that in the back of your mind. And here would be an example. So let's say how we could use Lambda functions in AWS. And Lambda at Edge is just running it closer to the user. Let's say I have a video service, and I'm going to create a video. And the first thing I want to do is upload the video to the object storage. And the next thing I really wanted to do was then have the video transcribed. I can have a Lambda function send it to, say, Amazon transcribe. Maybe I want the video transcoded from what we recorded, say 200 megabit a second, to say MP4. And I could use an encoder protocol program on AWS to do that. And a Lambda function could send it there. I could even set up another Lambda function to kick off the AWS simple email service to email me that says video has been transcribed and video has been transcoded. And keep that in the back of your mind. This Lambda is just about automating. So now we'll briefly get into a topic I love to talk about, which is called network security. And when we're getting in this, we're talking about the security from the networking perspective, meaning we're not talking about how to create secure code checks, input validation, on the application development side. We're not really getting involved in identity and access management, meaning who are you? What are you allowed to do and keeping track of it? The authentication, authorization, and accounting. We're covering network security and how you can secure your cloud from an AWS perspective on the network. So we first have to think in terms of threat models. And a threat is realistically anything that can harm your system. A threat model is going to be a structured process that's going to evaluate your threats and your vulnerabilities in a system. And it's going to give you suggestions or countermeasures on how you can mitigate them. Now, we have to think about how complex our IT systems are getting. They're becoming more distributed and they're everywhere. So using unstructured approaches to think about our security, probably not the best idea in today's world, especially 98% of organizations are multi-cloud. We've got our data centers. We've got our cloud providers. Our users have information on their systems. Then they've got mobile phones and mobile devices that also have data. So think about that. And threat models typically work by identifying your IT assets and the types of threat agents that can cause harm to a system. So think about it that way. Some examples of threat models are Stride, PASTA, and CVSS. So why do we use threat models? Because it's going to help an organization make better security decisions and think more rationally. Because when it comes to determining what your security is, some of it is you need to understand what are you protecting, the value of what you're protecting, the risk to the business should the systems be unavailable, the quantifiable risks, for example, like if we lose a certain number of people's information and it costs, say, $150 on average per user, and we lose 150 million people's information, that's a quantifiable risk. Another quantifiable risk is an organization that's got $10 billion, say, of intellectual property. And if it gets compromised or lost, it destroys the business. That's quantifiable risk. But we also have to think in terms of non-quantifiable risks, such as brand damage and things that we should also think about for an organization when we think about threats. But threat models really help organizations to detect problems early and address them proactively. And that's the key. Nothing's perfect. We want to find it and we want to fix it before it actually becomes a security breach. And threat models are going to be useful in evaluating new forms of attacks, because new forms of attacks do occur. It'll help our organizations highlight the assets, the things that we're trying to protect, as well as determine any kind of controls. And it's going to help us with our compliance requirements. So we'll talk a little bit about AWS security, and I want to talk about the couple of things that we really need to talk about. The principle of least privilege. In this, we're going to get involved into multi-account strategies. We'll get involved in different types of things, IDS, IPS systems. So we'll have lots of fun in this section. But let's first talk about who is responsible. Now, whenever you're dealing with a cloud provider, they all have their version of a shared security model. And what is really meant by that? To sum it up, you protect your stuff, and AWS protects their stuff. But let's try to make it a little more specific. AWS will maintain the security of their cloud. Because if their cloud gets hacked and goes down, you go down, or you may go down, or your information will be compromised. And of course, we've seen cloud hacking events where people's information has been compromised. You have no control over that if the cloud provider gets compromised. You have control of your systems, assuming the cloud provider is whole. So you will maintain the security of your VPC. AWS will manage their servers, their routers, their switches, their physical load balancers, their firewalls. and the underlying technology, all those cables between you and your systems that you can't see. But you will be responsible for your authentication, authorization, and accounting systems. The users that you have, what your users are allowed to do, what your systems are allowed to do to each other, which are typically called roles, IAM roles. You will need to patch the operating systems on every virtual machine you have. Now, if you go serverless, you will not need to patch it because AWS will be patching it. But if it's your system, you will need to patch it. You will need to maintain the security of your applications. You will need to maintain the security of your configured options, meaning, do you have the right security groups? Do you have the network ACLs, those types of things? And you will have to maintain the security of your physical devices that are going to connect you to the cloud. I want you to think about this. Let's say you have the perfectly secured cloud, and you've got a direct connection to your campus. And the router that connects to the cloud is in the middle of the lunchroom, and anybody can just plug into it. All your security would be gone. So you need to make sure that your devices that are going to connect to the cloud are in a secure sort of manner. Now, here is the way you can really think about it. Here, graphically speaking, this AWS shared security model. You can see that they manage their servers, storage, databases, networking, their regions, edge locations, and availability zones. That's their stuff. Your data, you have to protect. Your operating systems, your firewalls, access control lists, all that stuff, security groups, you have to control that. Your data, well, obviously from the permissions, and ideally you encrypt it too, although most things are encrypted now by default. Your applications, if you deploy insecure applications, you will be hacked, and AWS can't be responsible for that because it's your stuff. And basically any kind of encryption strategies you choose to use or certificates that you're dealing with, you will be responsible for that. Now, I'm going to talk about a concept called the principle of least privilege. It's very similar to a concept called need to know, but principle of least privilege is basically don't give people access to more information that they need to do their job. Because if you do, there's a chance that that information will get out to the wrong people. They will use that information to hurt you. Kind of similar to, if you look in a military context, most soldiers are not walking around with a ton of top secret information because they don't need it to do their job. And when they do need top secret information, they typically have a clearance level, and they're only allowed what they need to know for their job, but not the extra critical things. Well, realistically speaking, that's kind of what we're talking about right now. So give people the least amount of rights to do what they need and nothing else. And if you terminate an employee, get rid of that as fast as possible. So to me, I look at authentication, authorization, accounting, and really what it is authentication is who are you or who do you claim to be? Authorization is what are you allowed to do? And accounting is what you did. So let's say I invited Mo to my house. And I met Mo in Florida recently. I enjoyed spending some time with him. We didn't have enough time, but to go back to my house and for him to meet my wife and my cat over there, well, actually he's met my wife. But let's just say that when Mo knocked at the door, I might have a camera that would tell me that it looks like Mo. And I'd open the door and I'd say, hey, Mo, that's you. And I would authenticate him. And then I'd welcome him in. Authorization would be allowing Mo to enter any room in the house, or use the physical therapy center in the house, or whatever have you, because that's authorization, what he did. And then accounting, which is the last component of this, is basically saying tracking what someone did. So when we talk about IAM, even though I said we weren't going to talk about it too much, I wanted to cover the basics. So I'll talk very briefly about ways that you can semi-segment your systems. AWS gives you the ability to do what's called a multi-account strategy. And what is this? Typically speaking, everything in an account is yours. And what if something goofy happened in your account? You could potentially damage your entire account. So you may be tempted to basically just buy 4 different accounts or 5 different accounts and keep them separate and just pair or share information between them. You can do that. But the problem is sometimes the more you buy, the bigger of a discount you get. And it might be nice sometimes to get one bill versus 5 bills and trying to figure out which department is responsible for which. So what a multi-account strategy is you can create a master account and effectively have multiple sub-accounts underneath them. And AWS calls those sub-accounts organizational units. And what happens is you can create a basically identity and access management policy. But in this case, it's going to be an identity and access management policy across which accounts can talk to each other. And AWS is going to call that a service control policy. And that's going to allow the master organization to define policies that can restrict at the account level what services and actions member account users, groups, and roles can take, including the root users. So it's really just like an IAM policy, but it's an IAM policy to govern the accounts or the sub-accounts, as opposed to a traditional identity and access management policy, which is for the user. So realistically speaking, you've got one company. And by having the company, all you're really dealing with is you're breaking it down into 4 mini companies and using consolidating billing and giving you permission boundaries in between the organizations. Here's another way to look at it. You've got a root account, and each root account has their own organizational units. And they have like various accounts you can have underneath them. Typically speaking, the point of doing this is you've got your isolation between your organizational units, and you have the ability to share necessary information between these units. And you have the ability to reduce the visibility of one workload to another. And why are you doing this? Because if you've got a big problem here, you want to limit the blast radius to here, as opposed to all these other parts of the organization. It's the way to compartmentalize data. And it's very similar to the concept of taking a network, breaking it into 4 separate networks, and then running BGP between them. Very similar concepts. Okay, I think we are at the point where we're going to transition to another member of my team, but let's see if anybody has any questions real quick. Samson, is UDP and not greedy like TCP? In other words, why does UDP not have a slow start and congestion avoidance like TCP? Or is there? So actually, Samson, that's going to get into the reliability and the way TCP works. Mo, I'll let you work with this because you were having some fun with congestion avoidance. And if you need any help, I'm always happy to partake in here.
Yeah, just like what Mike just alluded to, right? TCP, it's up to what your application is built on, right? When you build an application, you need to decide whether this application needs to be built on a reliable protocol like TCP or an unreliable protocol like UDP, right? And so by nature, UDP is not a reliable protocol. And so the whole idea of more reliability and having traffic be sent and acknowledged, that's not part of UDP. So it makes more sense for real-time protocol, for real-time traffic, right? Like voice, for example. For example, if you have a voice traffic, it doesn't make sense to have a congestion avoidance because you need to send that traffic in real time, right? Regardless of the bandwidth needed for that traffic, you need to send it in real time, right? And then you have different codecs that control your the quality of your traffic, but also the size of that traffic, right? And so it's more, UDP doesn't have congestion control, right? So really the congestion control becomes something that you control on the network itself, right? Rather than the application itself, right? And so, or apologies, what I meant is something that's controlled by the network or the application, but not the protocol that's used by the application. So with TCP, you can still control the congestion on the application itself, but the protocol, which is TCP, in reality is the protocol that inherently has congestion control, right? But you can still control TCP on the network side, on the application side as well. So it's really, it's a design decision that was made for UDP because there's some sort of traffic where congestion control makes no sense, right? And getting an acknowledgement makes no sense because you just need to send it from point A to point B in real time. I hope that answers your question.
Yeah, so Samson, I'll add to this a little bit. So let's look at the way TCP is used for and why TCP exists. TCP is used for a reliable connection. So if I want to send Mo something, or I want to send Benedict something, I need to know that Benedict got it. And in order to do that, I have to send it to Benedict and then ask Benedict, did you get it? And he has to say, Mike, I got it. So for that to occur, so the way TCP works and the way it sends its messages is as follows. I want to send Benedict something. So I send Benedict something. He gets it and he says, Mike, I got it. So now I want to speed up. I'm going to send him 2 of some things. And Benedict's going to say, Mike, I got it. So now I'm going to send 4 of something because my goal is to get it to Benedict as fast as possible, right? And Benedict is going to say, I got it. So now I'm going to send 8 to Benedict and he's going to say, I got it. And I'm going to keep going up. And that's why where Mo says it's greedy, because I want to send it there as fast as possible until I don't hear back from Benedict that he got it. And then I'm going to slow down and I'm going to start this process again. And that's kind of where I'm going to find my maximum throughput. Now, we do that because we want it to know. Now, by comparison, UDP is not meant for reliable transport. So let's say I wanted to send cat videos over there to Benedict over there in Canada. And I'm sending him a cat video, and for some reason, for a quarter of a second, the screen froze, and then it went back to the rest of the cat video. Benedict has no problem with that because it's a live video. So for information that does not require reliable transport, like live video, we send it via UDP, and UDP has no flow control because it's just packets that get sent along the wire, and they just get delivered as they're sent in. And let's talk about why I wouldn't want flow control on video. Imagine if I said I sent Benedict a message that says, I like cats, which is completely true. Now, what if I said and he came back and I said I like cats, but all Benedict saw was I and then cats, and then I had to retransmit the like after the fact. Well, that wouldn't exactly say I like cats. It would say I cats like. So any kind of real-time, anything that we need in terms of, say, voice or in terms of video is done typically via UDP because we don't want that reliable transport or retransmissions. Can you use, you're just curious if you use threat modeling and threat hunting under interchangeable? Not really. So it's going to depend on how academic you're going to get and how geeky you're going to get. But threat modeling is more of evaluating, and threat hunting is more looking for those threats. So modeling is more at a more managerial level. Hunting is you're going to go out there and find them, more vulnerability scanning and seeing where your weaknesses on your systems, code checks, that kind of thing. So is it you coming up, Benedict, on securing application flows?
Yep.
Okay, so give me a hashtag cloud networking so I know you're awake, and Benedict is going to start talking about securing your application flows. And if you just joined us and you hadn't found out or signed in and received any of our labs, sign up for them now. They're in the chat box. They're also going to be in the description of this video, and they're completely free.
All right, thanks, Mike. So Mike started the discussion on security in the AWS cloud, and I'm going to continue from where he stopped. So the first item we want to look at today is how to secure the flow of traffic to your applications in the AWS cloud. So these are the recommendations from AWS, right? So it's recommended that you use TLS encryption to encrypt data in motion from the client to your application servers. Encrypting the data keeps it safe from eavesdroppers or anyone who gains unauthorized access to your account. It is also recommended to use security groups to protect your EC2 instances. In this case, it will be the web applications running on virtual machines, right? So that keeps the bad guys out. It is recommended to use a network access list to control access at the subnet level, so you can determine who has access to these applications and what they can do. Of course, identity and access management is key in securing your workloads in the cloud, as it determines who has management access to your applications. And of course, it is recommended that you use a web application firewall to protect your applications from common web application attacks. Then in terms of monitoring, it's recommended that you use the VPC flow logs to monitor traffic that is coming into your applications and leaving as well. Then AWS also has some recommendations about securing inbound traffic to your VPC, right? So it's also recommended to use a firewall, network firewall, at the edge of your VPC to filter traffic that is coming inbound to your network, so that it can drop any suspicious traffic and keep your infrastructure safe. The use of a web application firewall at the edge is also recommended to protect your web applications. The AWS Shield is a service that can offer DDoS protection to your services in your VPC. So it's also recommended by AWS to secure inbound traffic flows. Then, of course, the use of the security groups and the network access control lists as well just gives you that additional layer of defense when you're securing inbound traffic flows. Now, how about outbound traffic flows, right? You also want to monitor traffic that is leaving your VPC, because there could be some instances where some of your internal devices have been compromised. Let's say one of your servers is part of a botnet and is trying to report to the command and control center. The firewall can identify that malicious traffic and drop it at the edge. So use a network firewall to secure outbound traffic from your VPC. It's also recommended that you could use a proxy server, which serves like as an intermediary between internal devices and the outside world, such as the internet. So it keeps the identity of your internal devices safe, whilst permitting them access to the internet. It's recommended to use Route 53 Resolver, which is a managed service that can identify traffic going to malicious domains and then drop those traffic. So it's a pretty efficient tool, that one, the Route 53 Resolver. It's also recommended to use VPNs to secure outbound traffic flow. Of course, you know the VPN creates an encrypted tunnel which protects the flow of your data from your VPC outbound. Now, Mike spoke about the private link yesterday. There are some instances where you need to give access to external parties to some services in your virtual private cloud, right? Now, in such instances, there's no need to do VPC peering. You could just create a private link that will give them access to only that service that is specified. So it's also recommended to use the AWS private link to secure outbound traffic flows from your cloud infrastructure. Now, how about inter-VPC traffic? Now, when you do your VPC pairing or you use transit gateways to allow connectivity between your different VPCs, do you just want to allow everything? Nope. Like Mike said, information sharing should be on a need-to-know basis, implementing the principle of least privilege. So how do you secure inter-VPC traffic? Use your network access list to define what can come into the subnet and leave the subnet, right? So even if you have a VPC pairing, you can lock down access with your network access list to allow particular IP addresses or particular subnet to come in and go out. And that helps you to secure your inter-VPC traffic. Use security groups, which will protect the traffic at the instance level. So the security groups will be applied on individual EC2 instances. So even if you have a VPC pairing, you can create rules on your security groups that just allows certain IPs or certain subnets to, access that instance or that virtual machine. You can also employ the use of a transit gateway, which Mo spoke about yesterday. And the advantage that the transit gateway offers here to connect your VPCs instead of doing VPC pairing is that you can create route tables. So you can, manipulate the routing table to determine who can come in and who can go out to your VPCs. And then you can implement security policies at the transit gateway level as well. So it's also a good solution to help secure your inter-VPC traffic. And then, of course, we spoke about VPC peering as well. It allows you to connect to VPCs with private IP addresses, right? So that way, the traffic from one VPC to the other is always across the AWS backbone network. It doesn't go out to the internet to get to the other VPC. So that provides some sort of security and confidentiality for that kind of connection. So these are some of the recommendations that AWS has shared to help their customers secure inbound and outbound traffic flows, application traffic flows, and inter-VPC traffic flow as well. If there are any questions, we can take it now.
Hello, everyone. Do we have any questions from Benedict or from what I had said prior to the break? If not, we'll go back to the content. We just want to check in with y'all. Just want to make sure that you're learning and that there's no questions that we need to address. Okay, well, I'll get back to the content. If you're having a good time, if you could like the video, if you want to get more videos like this, subscribe to the channel, hit the bell to be notified of new videos because we've got a lot of new videos coming. And make sure to, if you don't have a copy of the AWS Labs and that we're dealing with, please sign up and you can get them completely free on our content management platform. Truth Factory, how do you secure all the resources within your VPC using a security group? You don't. The security group is the only way that is designed for you to secure one service. Protecting your VPC is going to be a combination of leveraging next generation firewalls, IDS, IPS systems, endpoint protection, hardening your operating systems, encrypting your data, leveraging a strong identity and access management strategy, training your people on which things to potentially avoid. And that's, I'm only scratching the surface of what's necessary to actually secure your VPC. But the security group is just to secure one service.
Fatin is asking, can we use SCP as a security measure? So what does SCP mean? Secure copy, or the policy to control access to organization units in a multi-account strategy?
Yeah, so let's address this. And that's why we try not to use acronyms like an SCP, because both Benedict and I aren't sure whether you mean a secure copy or you mean SCP. But let's talk about it in the context of AWS, just in case. So the whole reason they came up with these security control policies is a security measure. It's to limit who can talk to whom in between these organizations. So it's an identity and access management measure. But don't count that as enough of security. Count that as one amongst 100 other things that you're going to need to do to secure your systems.
So name not found is asking, what's the difference between endpoints and private links? So endpoints are like entry points, URL entry points into your AWS web services, right? Private links gives you access to particular services in a VPC. So if a third party needs access to your S3 bucket so that they can save information there, you want to use a private link to give them access to only that S3 bucket and nothing else. So that's basically the difference.
Okay, well, I love these questions because you guys are thinking. So we will get back to the concepts, and I'll start talking about restricting network access. Sorry about that. I muted myself right before I was ready to speak. So now let's talk about restricting network access. Part of a good security posture is keeping unwanted traffic out of your network. Let's think about how organizations have done this for centuries. If you've got a castle and say a king and a queen is in the castle and they don't want you to get in the castle, they put up the giant wall around the castle, right? And it keeps people from coming in because it's higher than we can jump. Well, realistically speaking, a firewall is a countermeasure just like that. And, we want to keep traffic out of our systems that doesn't belong, and we only want to allow the traffic that does belong. And what firewalls do, especially modern firewalls, is they will look at the IP address that's coming in. They will look at the protocol, TCP, UDP. They will look at levels now at the application itself and can see what's going on, say, inside of an HTTP or HTTPS header. They can even look at patterns of anomalies that don't make sense and stop it. But typically thinking, and that's going to be in the next generation firewalls and the such, but typically think of this as firewalls keep unwanted stuff out, and they allow you to go out to the internet and come back, but they don't allow outsiders to come in unless you specifically mention them. Now, AWS has their proprietary firewall, which we'll talk about. But understand, if you're a security architect or a cloud network architect or a cloud architect, and you're dealing with enterprises, you're probably going to be needing a next generation enterprise ready firewall. And there's companies like Cisco and Palo Alto Networks and Fortinet that make them, and you'll be able to get them from the AWS marketplace. But this is an AWS exam, so we will be covering the AWS firewall next, which does not have some of the robustness for some of the things that I'm actually describing, but it's there, it's native, and it works well. So keep that in the back of your mind. I want to briefly walk you through the way a firewall will work, just for a moment. In case you're not familiar with firewalls, if you truly understand firewalls, then you'll understand these things a little better. So let's say we've got a user that wants to access the internet. In this particular use case, I decided to use a cat because I thought, who doesn't like cats? And it would make the user kind of happy over here. So now we've got a user over here that decides she wants to go to the internet. And why does she want to go to the internet? She wants to go to the internet because she wants to go buy tuna. And of course, that's her goal over here. So let's talk about the way a firewall will typically work. Let me draw a firewall over here. And then let's just say, and I'm going to make up a website, www.worldsbesttuna.com. So Cindy wants to go here. So the way a firewall is going to work, all firewalls for the most part, is Cindy's going to go to the internet. She's going to go to www.worldsbesttuna.com because she wants to buy tuna of all those things. And her TCP request for the web page is going to go through her firewall out to the internet. World's Best Tuna will acknowledge her connection. They will respond to her connection, and then the connection will be allowed in. And here's the reason why. The firewall knew the traffic was coming from Cindy to worldsbesttuna.com. And the reason the firewall knew it is the firewall took state. And what happened is the firewall built a table that said message from Cindy to worldsbesttuna.com. And because the firewall has that state, which I clearly typed quickly, it knows to allow the response to Cindy to the worldsbesttuna.com. Now, let's just do this, and just for argument's sake, now we've got over here, we've got Sally the hacker. And Sally wants to go through the internet to steal information from Cindy. So Sally the hacker goes through the internet, it goes to the internet, and it hits the firewall. And Sally the hacker's information is not allowed to ever get through the firewall. So Cindy will never see that, and Cindy will be safe. This is because there is no state for Sally the hacker, and there are no rules in the firewall that says Sally the hacker is allowed entry into Cindy's home. So now that you know what a firewall is and what a firewall does and how a firewall works, let's talk about the AWS Web Application Firewall. And a web application firewall is a firewall that typically looks for web threats. And web application firewalls can fit very nicely with your next generation firewalls as well if you choose to use them. But what will happen is the firewall will run, and it will run on the server, and it's going to be constantly looking for exploits and things that occur. And the firewall will typically stop threats that it knows about. And when it comes to firewalls and the way they stop threats, they can stop them based upon a signature if the firewall supports it, meaning I already know what the issue is, kind of like your antivirus. Or firewalls can use anomaly pattern detection, which is they can look and say, this doesn't feel normal, block. So if any of you guys travel a lot for work, and you've ever, say, left your house in Palm Beach, Florida, and then gone to New York City to give a speech and San Francisco to give a speech, and the next day you're in London, and the day after that you're in Dubai, your credit card company may call you and or shut off your card and say, did you mean to do this? Now, that's happened to me lots of times because that's what my weeks used to be like. And then at one point, the credit card company got used to me just being in 3 countries a week, and it would say, Mike, okay, it would allow my card charges through. Well, modern firewalls can do that as well. Now, when we're talking about WAF, and WAF can't necessarily do all these things, it can do some of them, but not all of them. You can put your web application firewall on your CloudFront distribution and block the bad web requests before they even hit the content delivery network, before they even hit the servers. You can put your WAF on an Amazon API gateway to help protect your APIs. You can put it on a REST API, or you can put it on your application load balancer. And WAF will block connections to these edge locations before they get on your network. And WAF gives you the ability to control access that users can specify. So it's a firewall, so you're going to design a policy. Now, WAF can get pretty granular because it's a firewall. You can say, who's allowed to talk to whom or who's not allowed to talk to whom. And basically what you're going to do is you're going to create firewall rules. And you're going to be using, web ACLs rules or rule groups to do it. And basically rules are going to be statements that says, permit Sonny the cat to enter our network, because we know Sonny the cat's IP address, protocol port number, and we create an entry. Or block Sonny the cat from entering if Cindy doesn't like Sonny the cat. Not all cats like each other, but we have the ability with firewalls to determine who's allowed in and what we're allowed in. As a rule, in a firewall, don't let anything in except when you need to. So if you've got a firewall and you've got a server that's listening at HTTPS, open port 443 and that demilitarized zone specifically for that HTTPS server, but don't let the rest of that HTTPS or any traffic come into your network. So kind of keep about this. Now, rule groups in AWS WAF are going to be groups of individual rules that can be reused in other places. And you'll be able to monitor your WAF traffic metrics in CloudWatch, which is kind of nice. So you'll enable your WAF on your application. You'll create a policy that's going to determine what filters you need. And then WAF will analyze traffic based upon the policy. And if the traffic conforms to the policy, WAF will allow it. If the traffic doesn't conform to the policy, WAF will deny it. And if an attack occurs, you can create new rules to try to mitigate the attack. So here's kind of the way you could apply AWS WAF. You can pop it on your CloudFront distribution. You could pop it on your load balancers, for example. And you could pop it on your API gateways. Here's an example of if we were going to do an all AWS security environment. Not that we should, but if we could. And, the determining of what we secure is based upon, the organization's assets, what they need to protect, what kind of risk tolerance they have. Are they taking the risk, transferring the risk, mitigating the risk? And there's a lot of business decisions that go into that. But in this particular case, here's what it could look like. We could use WAF and Shield for DDoS protection. And then we can use the network access control list to protect a subnet. And then we can use our security groups to protect our instances. So that's putting some of the AWS security pieces together. So let's talk about preventing a distributed denial of service attack. What is it? Let's first talk with what is a denial of service attack. A denial of service attack is if I try to overwhelm your capability to serve. And by doing so, I make it that you can't legitimately serve your customers. So let's say for a moment, all of you just became web servers. Oh, you're all web servers. I'm a web server too right now. Let's be web servers. It'll be fun. So each one of us can handle 5,000 web requests per second. They come in, we can answer them. They come in, we can answer them. And we can each do 5,000. But we're all individuals and we're all our own little web server companies. Now, somebody sends 100,000 web requests to us, but we can only handle 5,000. What's going to happen? We can't handle the 95,000. We're either going to crash because we're so overwhelmed we don't know what to do, or we'll just be busy servicing some that the majority of the people won't be able to attach our systems. We're typically going to crash. So that's a denial of service attack. When a hacker sends more information than it can potentially be handled, and it overwhelms the server. Now, I can send a whole bunch of half-open TCP connections and overwhelm immediately the server's capability to even respond to anything else. And all I sent was bad information. So there's ways that we can mitigate some of these things that we're talking about. That's a denial of service attack. Now, what's a distributed denial of service attack? Well, right now, let's say all of you out there are servers, and I were to be a hacker. I'm not a hacker, but I were to be a hacker. And I take over all of you, and you're all servers, and you and me together, we all launch an attack on something. That's a distributed denial of service attack. And why is it? Because it's not just the one hacker that's out there. It would be all of us that effectively functioning as hackers, all to overwhelm a single company or a single organization. So DDoS attack, one hacker. Distributed denial of service attack, a hacker hacking into a whole bunch of other systems and then using all those other systems to hack in. Now you can see how easy it is to compromise 1,000 servers on the internet to take down a web server. So DDoS protection really matters. And so now graphically, I can walk you through what previously happened. Here we've got the attacker. The attacker has a control server. They infect a whole bunch of other systems, and then they take down a web application. So let's talk about preventing DDoS attacks. It's not going to be any one thing that you do, just like it's not going to be any one thing that you do for security. Here's some things to think about. In your networks themselves, control the traffic that's inside of each subnet. And you're going to do that with a network access control list. If a hacker gets on one subnet and they can't get anywhere else, the damage is contained. On every server we have, let's put a security group on it to protect that server. Is the server good enough because we put a security group on it? Absolutely not. Every server that comes up for the most part starts out insecure. Servers are listening on all these ports and they've got all these services running and every one of them can be attacked. So your servers themselves have to be locked down. Unnecessary services have to be removed. Open ports need to be closed. Servers need some anti-malware protection, for example, host-based firewalls, maybe some IDS, IPS systems on the servers. So now let's think about auto-scaling. How can auto-scaling help with the distributed denial of service attack? Well, this is one of those great things that the cloud does, and it does well, and auto-scaling can help mitigate against a DDoS attack. So right now, let's say I am a server and I can handle 5,000 requests per second. And I'm being DDoSed at 10,000 requests per second. I can only handle 5,000, so I auto-scale. And now I add 3 additional servers. Now 10,000 requests are coming in, and I've got the ability and capacity with the 3 servers to be able to handle 15,000 requests. So auto-scaling can actually do a lot to help mitigate against a DDoS attack. Now, you're going to pay for that DDoS attack because you're going to be paying for all these additional servers. But if business is critical, keep that in your mind that you can help survive it with auto-scaling. And businesses know their cost of downtime. Firewalls. Adding a firewall that can recognize a DDoS attack and stop it, huge advantage. AWS WAF can recognize common attacks and dynamically apply policies to mitigate them. Common attacks. Some of your next generation firewalls can look for patterns of behavior that don't look right and can do it. And AWS WAF can integrate with some open source abilities to do some of that. So it can do that. But your mileage may vary on firewalls. And then AWS Shield is great DDoS protection that gets placed on the CloudFront content delivery network. And it's typically available at no additional cost to organizations using AWS WAF. And of course, you can get Shield Advanced, which has got much better protection. And you can add that to, say, a virtual machine EC2 instance, load balancer, CloudFront distribution, Route 53, and even your Global Accelerator. So let's talk about the difference between Shield Standard and Shield Advanced, because there's a big difference here. Shield Standard's free, and it's going to protect against common DDoS attacks. Common ones, normal ones. So say 96% of the most common ones, which is pretty good. You can think of your SYNAC floods, your reflection attacks, your HTTP slow reads, common attacks. And AWS Shield Standard is going to block based upon a policy. You set it up. Don't allow this in, and it'll block it. But it's static. It's based upon policy. Now, when we get into Shield Advanced, which you're going to have to pay for, you're going to get much better DDoS protection. Not only can you put on your load balancers, virtual machines, CloudFront, or REST 3, but now we're starting to get some intelligence into our DDoS mitigation. And it will look for patterns that are abnormal. And Shield can deploy, say, an ACL to mitigate that attack when it occurs. And Shield will allow visibility and notifications for Layer 3, Layer 4, and Layer 7 attacks. And for organizations that purchase AWS Advanced Shield, they're going to get a team at AWS that will help them if they have a DDoS incident. And that's 24/7. And for that to occur, the organization needs to, realistically speaking, have business or enterprise support. Keep that in the back of your mind. Just see where I'm at over here. Okay, so let's briefly talk about CloudFormation scripts. And in the world of cloud computing, and I don't care whether you're in a Nutanix data center, an OpenStack data center, an Azure data cloud, a Google Cloud, it doesn't matter. You have the ability to deploy what's called infrastructure as code. And what are we really talking about here? The ability for a developer or a DevOps engineer or a cloud engineer to write a script, or even ChatGPT to write the script, honestly, you can use it, that'll write a script that will literally go to the cloud provider and open up or set up a lot of things for you. Now, when it comes to automation, if we're good at it, we do a great job. When it comes to automation, if we don't know what we're automating, which sadly is most of the cases, we automate problems again and again and again. So keep that in the back of your mind. But here's one place where infrastructure as code is going to be very helpful. If I have an infrastructure as code environment, I can create a specification of this is the way something's supposed to be done. Say the operating system has all the vulnerabilities patched, all unnecessary services are turned off, there's no certain use or questionable applications or settings that can potentially be harmed. And if I have one of our engineers launch this infrastructure as code script, I can standardize something good the way I want it to be. And in a world where 98% of organizations are multi-cloud, your engineering team is probably better off using a infrastructure as code tool like Terraform that will work across all providers. But we're in the context of AWS. So AWS has the concept of a CloudFormation script, which is the AWS branded, AWS managed infrastructure as code solution on AWS. You can still use Terraform, but you could use this AWS service. And it enables your people to basically put their code infrastructures and templates, pop it in S3, launch the CloudFormation script, and infrastructure will be deployed dynamically, just like that. And CloudFormation, you can set up to provision 1,000 virtual machines. It's relatively easy to do. But that's what we're talking about. CloudFormation templates are going to be available with a multitude of options. The code on these is typically written in JSON or YAML format, like you typically would use YAML for Kubernetes as well. You can store the code locally. You can store your code on S3. And the code is going to be either used by the CloudFormation in the console. You can set up via the CLI, or you can set up via the API. And you pop in your code, and your systems will be automatically provisioned for you. Okay, I think it's time for us to switch to Benedict, so maybe we see if there's any questions before we do. Any questions for us? It is a known fact that the security landscape is so fragmented and security personnel can get bored with multiple school-ready tools to manage them. Is there a unified platform? So Tunde manage different security in a domain similar to Defender for XDR and Sentinel and Microsoft. So Tunde, it depends on how secure your systems you want to be. And what I mean by this is, look, AWS is a security center, which is good for your AWS stuff. But if you're dealing with an enterprise grade, you're going to need much more than, say, an AWS security center. And now let's look at it in the context of, yes, let's say a Palo Alto has their own good systems to manage everything, where Sentinel and Microsoft has their own good systems to manage everything. Would you really use a single vendor's firewalls in a high security environment? And here's the thing, different firewalls are like different martial arts. They each have their own strengths and they each have their own weaknesses and things that they catch. And if I was going to build a martial artist, maybe I'd teach them some jujitsu, I might teach them some boxing, might teach them a little karate along the way, and they'd be better armed. When I design a high security architecture, I may want some of the things that Palo Alto does best, and maybe some of the things that Cisco does best, or does differently. And that's where you're going to get into your challenge. As you get better and better and better security, you're going to often get more fragmented in your tool set, because that's where things get ugly. So when it comes to security, can we use the cloud native tools? Does it make sense? And if so, we got our security center. Now, for most enterprises, that's probably not going to be enough. So now they're going to have to determine, do they want to look for a single vendor solution like a Palo Alto? And then there's some pretty good options, and a lot of the Palo Alto stuff is integrated natively in AWS. Or do they want to build the best of breed, which will use the best tools from each vendor? And by doing so, they're going to get a much more robust security platform and a whole lot more complicated management. So that's an architectural choice they're going to have to make after evaluating all trade-offs. The capability of their people, their goals, what assets they're protecting, the value of the assets they're protecting, the risk of the access to their business continuity plan. Great question. If either of you guys know of any good tools that are out there, we all tried to make HP OpenView work many, many years ago to make that look good for network management, but it's hard to find really good tools. How do you determine a good source for protection? You test. But I'll also, Lady Godiva, give you some other things to think about. So one of the things that you do is you actually have people try to break into the systems. You hire good ethics. You have a proof of concept environment set up, and you have people that are ethical hackers try to break into the systems. You have your QA test engineers try to break in, and you'll be able to see what you get. But let's take it back a step. Who's going to really buy these architectures? The chief information officer, the chief information security officer. They're going to be the people that are there, that are going to be your customers. Now, if you are a chief information officer and you buy from Microsoft, and it doesn't work because Microsoft has a failure, nobody's going to fire you for buying Microsoft. They're the biggest enterprise computing platform in the world. And now you deal with Billy Bob's company. And Billy Bob's got a better product than Microsoft this month. And next month, Microsoft has a better product. But Lady Godiva, nobody's ever heard of Billy Bob. Billy Bob's security company. And you make the investment in Billy Bob's because it is the best. And then it doesn't work because all technology breaks. It's just a matter of when the technology is going to break, not if it's going to break. And now you get fired because you bought Billy Bob's product, not the standard, which was Microsoft. So you're going to have to attend conferences. The organization that you work for is going to have to evaluate the technology and speak to the vendors that are out there on every architecture, because every architecture is going to have different strengths and weaknesses. And in every architecture, we may have to do certain things that would make it a little less secure because of an architectural decision we have to make in order to make it work. And then after we evaluate those capabilities, then we might actually say, okay, given the constraints that we have, the Cisco product is the better one, or the Checkpoint product is the better one, or the Palo Alto product is the better one, or the Fortinet based upon their needs. Kind of like if you were going to buy a car, then you would see what kind of car do you need based upon what you're trying to do. Do you get a minivan? Do you get an SUV? Do you get a race car? Hope I answered that. So Tundi, has AWS leveraged generative AI for security and reverse engineering of malware? Tundi, this has been going on for years where people have been using AI to reverse engineer malware and try to see what's been going on. For the most part, all your good security providers have had AI integrated into their systems for many years, at least 5 years now. Okay, well, if it's time to go back, give me a hashtag AWS Advanced Networking. If you just joined us, we've got some free labs that we'd love you to do, about 2 full days worth, to help solidify the training we've done over the last 3 days. Please make sure to sign up. The link is in the description, as well as the chat box. I think that's you, Benedict.
Yep, it's me again. So let's talk briefly about the AWS Cloud Development Kit. Thanks, Mike, for introducing CloudFormation and how it helps us to achieve infrastructure as code in the cloud. So AWS Cloud Development Kit is actually a tool that is actually an infrastructure as code tool that is offered by AWS. It uses CloudFormation to push code to the cloud and deploy infrastructure. So the Cloud Development Kit is an open source software, right, for developing AWS-based infrastructure, right? So it's an open source software framework used to manage AWS-based infrastructure. So it's proprietary in this sense. So how it works is that it makes it easy for developers to, define cloud infrastructure in the common programming language such as Python, Java, C#, and then deploy them to the cloud using CloudFormation. So what it means is that you go into code and then you write a script to deploy an S3 bucket, right, in the cloud, and then you use CloudFormation to push that code to the cloud to deploy the instance. So rather than going through the normal way of building your infrastructure, which is through the graphical user interface or through the command line interface, right? You can just deploy your infrastructure programmatic using this AWS CDK in a program manner, right? Now, how exactly does it work? It works by it does some high level abstraction here, right? It builds objects, right? And then you can configure these objects as reusable code, which is called constructs, right? And then these constructs are combined together to form stacks and apps. And then you can deploy these stacks and app to the infrastructure using a cloud formation template. So this is what the diagram is going to look like. Just share my screen briefly. So you have some abstraction which is done here. There's a CDK application, and then you have constructs there which are combined to form apps and stacks, like I said. And then to deploy these apps and stacks, you compile them and then use a cloud formation template to deploy it to the cloud. So, this is infrastructure as a code typically through the cloud development kits, right? We're still going to talk a little about infrastructure as a code later on, but this is just to give you an idea of a service that employs infrastructure as a code to deploy resources in the cloud. So this way, you just deploy the services from your CDK application, and no need to go into the graphical user interface, the management console, or the command line console. It's all done in code. And why would a company use the AWS Cloud Development Kit? Well, it makes onboarding easier, really. Okay, so you're able to you've already defined code, for example, of an S3 bucket. So if you want to deploy an S3 bucket in the cloud, it's just easy. Just go to your CloudFormation template and then call up the constructs and then deploy it to cloud, right? If you were to go through the management console, you would log in, go to S3, set it up, choose the size, encryption algorithm, and stuff like that. But if you already have this in code, it just takes a few minutes for you to deploy. So it makes the cloud onboarding easier. It also helps developers to roll out applications faster and with more accuracy, especially in this era of DevOps, where developers are churning out applications day by day in a fast and efficient manner. So it supports that. And then it helps to, enforce security measures, compliance requirements. So if you have a requirement by organization that all S3 buckets must be encrypted with AES 256 encryption, right, by default. Now, if you have this already defined in the cloud development kit, ready to go, ready to be pushed by CloudFormation, there are bound to be less mistakes than if an administrator goes into the cloud and is not really aware of the security policy that says AES 256 and uses something that is less secure to deploy the template. So in that sense, it gives you the ability to maintain your compliance requirements with regards to deploying applications in the cloud. So these are the benefits of using the AWS Cloud Development Kit. Could take some questions now if there are any.
We're back to see if you had any questions before we transition between us. If not, we'll go right back to the content, which is totally fine. All right, let's go back to the content, huh? I will begin talking about the service catalog. Okay, so let's talk about the AWS service catalog. So in my first networking engineer job, I was given the name Sniffer Boy because what I literally did in my first week was I took a protocol analyzer, which they used to call a sniffer, and started plugging it into every single port on the network that I could find. I was creating something called span ports and checking hubs so we could find all the things that were gonna get you. And I can remember I found people sharing Napster videos and all these other things on a corporate network in my first job. And the key is, why did we do that? Because we didn't know what people were putting on the systems. Now, when you're designing your systems, you want to control what's put on the network. And you ideally want it to be things that you want. That's one of the reasons you would use infrastructure as code. Standardize on a certain way to manage your operating systems. Well, the service catalog is a way to help you control what's going to be placed on the systems that you design, if you're the architect, and on the systems that you build if you're an engineer. And what happens, you take this AWS service catalog and you're going to create a list of things that are approved. You can use these certain virtual machines that are pre-made, these kinds of servers, these specific software pieces, these specific databases, and these specific application architectures. So you design it, you create a policy, and then when people actually want to deploy something, they can deploy what you know is right and you know is good versus whatever they want. So for here, we're realistically, what are we talking about? The user is going to access the service catalog. They're in the service catalog. They've got some pre-made AWS CloudFormation scripts. Poof, launch what you want. It's built, and it's going to be built within the same parameters that are actually that you've actually determined to be successful. So that's realistically speaking what we're talking about over there. So another way that you can think about how to try to make this a little better is you need to store your secret stuff somewhere. I mean, when I was younger and we started to push heavy-duty password policies, people put sticky notes of the passwords on their desk, and they'd have 10 different sticky notes. It was kind of scary if you realized it from a security hole. We tried to push strong passwords so people put sticky notes where everybody could see it. But where do you put your sensitive information? Where do you put your passwords that matter? Where do you put your license keys and other sensitive information? You have to store it somewhere. So in AWS, we have the concept of the Systems Manager Parameter Store. And this is a place where you can store your secrets or secret information in AWS. And the Systems Manager Parameter Store will provide a means to store your sensitive things in an encrypted manner. You can store, the Systems Manager Parameter Store can actually look at your managed instances and see if they comply with what they're supposed to. And if not, it can report policy violations. It will keep your code separated from your password. We can use it for audit access, and it's a great way to track password use. So keep track of that is something that we're actually talking about. Now, the concept may pop up on an exam, so we'll talk about it. This is not a comprehensive answer for end-to-end security, but this is what you might typically think about from a test perspective on securing an AWS managed database. Use multi-factor authentication to make sure that only authorized users can access the database. Do not use a Bastion host to connect to your database, because if the Bastion host is compromised, then your database will be compromised as well. Make sure for your databases, you've got a strong identity and access management access policy to limit who's allowed to use the systems and what they're allowed to do. When we deal with AWS databases, please use a security group on them as a host-based firewall to protect stuff from coming into them. On your database, enable TLS encryption to protect your data in transmit. Leverage the AWS key management system to make sure, which is a manner to actually manage your encryption keys. But in this case, make sure you manage your encryption keys, which are going to be used to encrypt your data at rest. And monitor and log any activity within your database environment to help detect unusual behavior. Now we'll talk briefly about AWS config. And AWS config is going to be a service that's going to help assess, audit the evaluations, the configurations that you have in AWS. One of the good things about AWS config is it's going to give you a good opportunity to log and track changes. And when a change is going to be made, it'll be noted, it'll be logged, and you can see who did what and when. And if something gets broken because of a change, it's good to know what was actually done, and then you can unbreak it pretty quickly. You can also set up AWS config that anytime a change is made to send, say, a text message or an alert. And you can integrate that into the Amazon Simple Notification Service to do so. One of the things that's really great about config is it's going to provide constant monitoring of your configurations. So you know what they're supposed to be configured out. You know what your systems are supposed to be. And if something changes, or when a change is made that violates your policy, you'll get an SNS alert. You'll get notified of it, so you can do something about it quickly before it becomes a big issue. Now, one of the most critical things for high availability and high performance and high security is a very good change management environment. Being able to know what the change is, having the change actually, checked by an architectural review board to see what the impact of the change is on other key components of the environment. Determining when to make the change, for example, and how to test after the change. Now, in real high availability, high performance environments, you're going to have to do that. But, lots of times changes get made and you don't know because somebody does it. And for organizations that don't have the best change management policy, AWS config can really help here because it can give you some information on what was changed. And even on organizations that do have a good change management policy, at least you'll be able to see that the change was made and track the change that was made in your configurations, in addition to the architectural planning that would occur. And AWS config can integrate with CloudTrail to track changes. And that'll make it much easier to revert should you have an adverse event. So how do we set this up? A configuration change, or how is it going to work? A configuration change is going to be made. AWS config will note the change, record the change, and it'll do it in a consistent manner, so you'll be able to mine through this later. AWS config will then check the change against an organization's policies, and then config will notify you that a change has occurred. And you can get this notification as a CloudWatch event, a simple notification service, or use other AWS features to do so. So I like to visually look at it this way. You make a configuration change. AWS config will monitor the change, and then you can obviously see the changes that were notified, maybe CloudWatch, S3 logs, and API call. So let's briefly talk about Certificate Manager. And then I think we'll end on Certificate Manager, and then maybe we break for lunch. Actually, you know what? I think we'll go all the way up to Amazon Macy really quickly. So let's talk about the AWS Certificate Manager. In a world where you're going to need TLS encryption and public key cryptography, those kind of things, you're going to need certificates somewhere along the line. And there's lots of places where you can buy security certificates, but you can get them directly from AWS. And if you do so, it's going to be relatively easy to do so for your things that are on AWS. And Certificate Manager is just, realistically speaking, an AWS service to centrally manage your SSL TLS certificates in the AWS cloud. So you want to put a certificate on your website, you can get one from the AWS Certificate Manager. And Certificate Manager is going to enable the simple provisioning, management, and deployment of certificates, whether they be public certificates or private certificates, for you to check the integrity of your internal applications. Certificate Manager will allow you to deploy certificates on AWS resources quickly and easily. And generally speaking, Certificate Manager provides free public certificates. And you can apply these certificates to things like your load balancers and your API gateways. So kind of the way this would look is, you go to Certificate Manager, you order your certificates, and you put them on your load balancer or your CloudFront distribution. So there's really two options when deploying your certificates. You've got traditional Certificate Manager. And this is what you're going to use if you're looking for security and encryption using TLS for your web applications. And you're going to use a Certificate Manager, put it on your load balancers, your CloudFront distributions, your API gateways, in order to secure your communications. But there's also the ACM private CA that's offered by Amazon. And this is going to be for communication inside of your organization. And it enables an organization to create an element of hierarchy. And this enables an organization to issue private certificates for certain users or computers or applications or services or servers or devices inside of the organization. You've got to remember, private certificates can't be used on the internet. Public certificates are used on the internet, but private certificates you can get from the ACM private CA from Amazon for an additional cost. I can briefly talk about a couple of the service of Amazon Guard Duty. Guard Duty is basically an automated security monitoring service. And what happens is you're going to get a lot of logs, CloudTrail logs, DNS logs, VPC flow logs, and Amazon Guard Duty is going to monitor these. And it's going to look for patterns of behavior that are anomalies. And if it finds something that doesn't feel right, it's going to notify a systems administrator so they can do something about it. While we're at it, we'll briefly touch on Amazon Inspector, which is another security assessment service that's going to help improve the security posture and compliance inside of an AWS environment. And Inspector is going to automatically assess applications for exposures, vulnerabilities, and deviations from what it determines as best practices. And after performing the assessment, Amazon Inspector will give you a detailed list of findings and what it ranks in priority level of severity. You can use Amazon Inspector to help with security assessments, check for unintended network accessibility. Maybe one of your EC2 instances on the public internet and you don't know about it, or the systems haven't been patched, that kind of thing. And then we will end on Amazon Macie, and then break for lunch and then come back afterwards, which is a fully managed data security and data privacy service that works by using machine learning to discover and protect your sensitive data. Macie basically provides an inventory of your S3 buckets, including a list of unencrypted buckets, publicly accessible buckets, which is a big issue, and buckets shared with AWS accounts outside of those that you've defined in AWS organizations, because they can be big security holes that you don't own. And when Macie discovers things, it'll apply machine learning and pattern matching techniques to help you select and identify and determine who to alert of sensitive data. So basically, Macie might find some sensitive data or something that looks like it's personal identifiable data, and it can give you a notification. Are all these machine learning systems accurate? Sometimes they give you an alert on good data. Sometimes they give you an alert on bad data. So I feel like it's a good time to break for lunch. Let's see if anybody had any questions very quickly before we break for lunch. And then we'll come back in 1 hour. Okay, we covered a lot of stuff so far today. When would you use the CDK over CloudFormation?
So, hi, Nigel. So, CDK is actually a tool that employs CloudFormation, right? So, you use CloudFormation templates to push code to the cloud. CDK allows you to combine your constructs as apps and stacks, right? And then you use the CloudFormation to template to push those codes to the cloud. So CDK is a tool that employs CloudFormation.
Why Bastion hosts are not recommended. So William, I want you to think about this. And I have two ways that I could allow access to my systems. Access one is if I've got a direct connection to my cloud provider, I can access my systems through my direct connection. Access two is I've got a highly secure environment from a network VPN device to the AWS environment. Again, highly secure. Here's what a Bastion host is. I got Billy Bob, who's not a security expert, that either takes a Windows system or a Linux system and sticks it on the internet. Billy Bob does not know operating system hardening and how to make a completely secure operating system. They then put two network cards in it, one inside the system and another one inside of my network. And I either Windows remote desktop to the system, which is worst case situation, and jump out of that Ethernet port into, say, my database or my application, or I SSH into a Linux machine and then from there jump onto the network. Now, I just stuck a computer in the middle of the internet and used it as a jump host. Now, it's so easy to hack that system. Now, if I wanted to do it correctly, I might take a network load balancer and front end two next generation firewalls and allow the IPsec protocol to a specific demilitarized zone. And in that demilitarized zone, I can put an access control list to protect that subnet. Now that virtual VPN concentrator that I'm going to use is going to be a Linux system. So I can put a security group on those Linux systems themselves. And then on those Linux systems that are going to be the VPN concentrators, they're going to be pre-made designs from a company like Palo Alto, where they spent experts and millions of dollars learning how to optimize the operating system where their virtual machine is there. And that is going to be a hardened system just to allow IPsec access. And then from there on my demilitarized zone, I can give them control over where I allow them. So the question is, do you stick a virtual machine in the middle of nowhere and call it a jump host? Or do you properly protect a VPN concentrator, which is a security device that's been purpose-built by security companies to do this? And secure that in a very secure demilitarized zone protected by firewalls. That's what I do. But, you know, I don't I didn't spend $15-20 million learning how to perfectly secure and penetration test an operating system like a security company would. So I'll ask them to do it. So it's a good way to share root log on amongst admins.
So it's not recommended to use the root admin credentials for administration of your AWS console. In fact, what is recommended is that you use the root credentials to create administrative accounts for the different admins who are going to be managing the account. And come to think of it, if you're sharing the root account details with all the administrators, if someone goes in and deletes an S3 bucket, who do you hold responsible? There's no way you're going to find out which of the admins did it, because you're using one root account for all the admins. So it's not recommended to do that.
Yeah. Would AWS Certificate Manager be a good choice in multi-cloud? Minesh, almost anything that begins with AWS, like DynamoDB, Amazon Aurora, probably something you don't want to use in a multi-cloud environment. So there's great certificate authorities that you can buy your certificates from. There's nothing wrong with using these AWS certificates as a certificate manager. They're fine. But there's lots of companies that you can buy enterprise-wide certificates from that you could use on and off of AWS. But if you're an AWS shop, maybe it's an organization that doesn't need high availability. Maybe it's a small to medium-sized business. It's all there, very simple to do. With Bastion host pivoting, can you conclude that a remote access VPN with a slit tunnel? So I don't know what you mean by pivoting, but I'm talking about making sure that your remote access device is much more secure. Now, generally speaking, split tunnels are a bad idea because they potentially allow risks into the system. So whoever's going to be coming in to access our system should never be allowed to be using a split tunnel. But with a good VPN concentrator and a good system, I can make sure when someone tries to initiate a connection into that tunnel, I can check not only who they are, but I can also check and make sure their operating system has a minimum level of security. They have specific anti-malware, anti-patches, and I can enforce a policy on them. So I've got much more control by setting it up as the way an enterprise would. And an enterprise doesn't allow remote access into their critical systems via Bastion hosts. Now that's different than the Microsoft Bastion host service, which is realistically speaking an Azure managed VPN. They just called it Bastion host. What's a demilitarized zone? So when you design an architecture, you don't want anybody to be able to allow anything inside of your systems. Like all public access should be restricted for all your internal systems. But then what about stuff that needs to be reachable from the internet? What you do is you create a barrier network outside of your system that you partially protect. So I would create a demilitarized zone, which is for my web apps, which is where I would put my HTTP and HTTPS stuff. Only that would be in that demilitarized zone. I would create another environment for remote access where I would have VPN concentrators and only allow the IPsec protocol in, because that way nothing else could be hacked on there. I might have some other servers for file storage that I wanted intentionally on the internet. I don't want that in my system for sure. So I might take those secure FTP servers and create another special subnet for them where people can upload files. Okay, well, let's do this. I don't want to gyp anybody on lunch because everybody loves lunch, right? So we will break now. We will come back at exactly 1:15 p.m. I'm sorry. We will come back at 2:15 Eastern time, and we will get back to the fun. So if you haven't liked the video, please give it a like. Please subscribe if you haven't subscribed, and we'll see everyone back in about an hour and 8 minutes.